Good night, sir.
Good night. Okay. See if my screen froze. Right. Yep. Really. Oh God. Why is this freezing right now? All right, guys, give me a minute. My screen froze. All right, we are ready. All right, we're ready to go. How is everybody doing right now? How is everybody doing? Are we good? Are we good? All right, what I'm gonna do, I'm gonna send the link for the live in the group. Please just put it on your status or send it to somewhere where people doing CXC. All right. So
Sir,
yeah,
you
it's in
just
the,
start or long time?
we not start yet.
Oh, come friend.
So I ask you status that's the minute. Put the live upon the status. So we can get a couple people for join. Because a late hours now, but we still have to kick it. We're gonna kick it right now. Going on right now. Stop marking my screen. All right, everybody. We're ready. We're going to go through as many questions as we can. We're going to try to finish the paper. Yeah. So basically, we just mark the screen. All right, let me just come out and go back. Somebody just mark the screen. Guys, be careful of the markings. All right. All right. So pleasant afternoon, everybody. One more time. Tomorrow is the exam, and we are gearing up to give it our best shot. You get me? Yeah, we're gearing up to give it our best shot. Remember, no gel ink. Don't carry any gel ink. That's not going to work. No gel ink. Um, do not write with pencil. You only draw upon your graph or draw. If you're drawing anything, you use pencil. But do not write your exam with a pencil. Don't do it. Okay, write with a pen, and it's okay if you make a mistake. Cross it out. Move on. All right. Do not write your exam with a pencil. There will be no time to rewrite. You're gonna strap for time, so honestly, don't waste your time. Plus, you don't get marks for neatness. Let me tell you straight. All right, CXC only care about the answer and how it is written up. Don't care about whether it's neat or anything. Honestly. All right, let's get into it. All right, so we're running into question one. All right, so we're going through. All right, a typical question one. We're gonna utilize our calculators and so on and so forth. So the first question says here, it says here, using a calculator or otherwise, evaluate each of the following. Give your answer to two decimal places. So you pay keen attention to whatever they have here. This can go on your calculator and you work out your thing. So basically, this 73.18 will be there. So you do your multiplication right there, 5.23 times 9.34. All right, and you're gonna get some 40 something. All right, give me 1 second here. Why is this doing this to me here? Hold on, guys. All right, you're gonna get some 40, 48.
48.848.
48.848.
Sounding good. Very good. And then now you just do a final subtraction. Do a final subtraction for me. 73.18 minus who's marking the screen?
Sir, the
Henry,
answer sir, the answer is 24.33.
all right. So we have 24 point. Give me more than that first. Give me the real thing first. 24.33 about 1/8. And
1
then
8. Yes,
yeah,
sir.
and then you do the rounding off to the final answer as you suggested. All right. So remember now you're rounding off. This is this digit that is in the spot. Next door is a 1, so the spot remain. You get your 1 mark and you're gone. So not a big deal. All right, not a big deal right there. Let's go to the next question. So, all right, hold on. So mark me thing, you know. Hold on. All right. All right, there we go. The second question, I'm still going to say follow these simple ideas where we're just going to work out what is on top first. All right, no biggie. So we're going to square 3.1. So 3.1 square. Square your 3.1. Okay. So what we really have here is 9.61 over 6.1. That, and then you're going to add this after that. Makes sense? So do the division now. 9.61 divided by 6.17.
1.558.
And just add 1.12 to it. Add it to it. All right. You're going to get some 2.677 and it goes on. But remember now, you're going to what? How many decimal places? 2. So this 7 is in the spot. And there is a number here between 5 to 9. So the spot goes up. The final answer, 2.68. Right? 2.68. So there it is. This part of the paper is like warming up. We are CXC making sure that you're grabbing some marks, right? So you want to make sure that you catch these. Don't miss them. Don't miss them. Don't miss them. All right, let's keep it going. Remember, ask a question as soon as you feel uncomfortable. I'm here. I am definitely here. All right. So Jenny works at Sammy's restaurant and is paid according to the rates below. So here's Jenny's pay rate. And this is weekly agreement. Jenny's weekly agreement. Basic wage. So this is what Jenny would have gotten ordinarily. Plus 0.9 or 90 cents are, you know, for each customer served. All right. So in a week when Jenny served N customers, her weekly wages in dollars is given by this formula. So you're seeing Jenny's weekly wages, $600 plus 0.9 N. All right, so we're seeing that. Quite clear. So first question, determine Jenny's weekly wage if she served 230 customers. So you're referring to Jenny's weekly wage. $600
Plus the 0.9 times
yes,
230.
Exactly. Times 230. So you're going to work out that. All you're going to do, just work it out. So
you get 207 for dear sister.
0.9 times 230, we get 207. 207 you mean, right?
Yeah, I said 207.
Sir, it's
207.
$807 for
Very good.
about
So
the
Jenny
600 and that.
$807 right there. So I saw these questions coming up. It's a Jenny maker $807, right? That's a very straightforward, just relax, easy way into it. And as you go. Normally, you know, they're going to increase what they want. So they said now, in a good week, Jenny's wage is 1,000 or more. That means it's greater than or equal to. Okay. Now it says, what is the least number of customer Jenny must serve in order to have a good week? You understand? So now they factor in inequality because Jenny's wage must be greater than or at least equal to $1,000. So that's an inequality we factor in now, right? So let's figure out now with Jenny's formula. Remember Jenny's formula is $600 plus 0.9 times a certain number of customers. We're going to take this idea. What idea? Jenny's wage. So Jenny's wage would have been 600 plus 0.9 N. This money must be greater than or equal to $1,000. So from here, we're solving an inequality, and then we're going to make a judgment call based on what we see. All right? Let's go back to the question. Let's go back to it. Let's go back to what's going on. All right. So we're going to subtract 600 from both sides. So we have 0.9 N is greater than or equal to, is that 400? Definitely. Yes, and then we divide both sides by 0.9 in an effort to find the n to isolate it. So 400 divided by 0.9, we're looking at this number. N must be greater than or equal to 444.4. Watch this now. In reference to customers, you know, customers are people. Make sense? Customers are people. So you can have 444.4 person. So guess what? N must be equal to what? 445. This is not rounding off to the nearest whole number, you know. This is understanding your inequality. The number of people cannot be less than 44.4. So if anybody write 444, I'm saying 444.4. So if you write 444, you're wrong. Because if you check this in the formula, you will not make $1,000. Your money will go short. So it has to be 445. And then you move on. Everybody good with that? If not, you can ask your question. I'm willing to listen and to share. Talk to me. Talk to me, everybody. We're good?
Yes, sir. I just me would think we do this in an exam,
That is why we are doing the marathon, man. That's why
Sir, let me write off this, sir, because
that's why, hey, you know, say if you're right with me, you stay there. If you're right with me, remember, you know,
I
live
catch this. Yes, sir.
Yeah, man, if you're right.
I just gonna take a picture, make it faster. Never finish.
Yeah, man.
Sir,
Yes,
Yes.
sir.
when you work it out, you get 1,000.5 for the money. So
Say make it.
okay.
And if you try it with 444 is short, now reach 1,000. So context there, because the member say I'm supposed to make 1,000 or more. So as long as they go over 1,000, we're good to go. This is the smallest number of customers that could produce that. All right, very good. Let's jump into another question. All right. So the next question now says this. The restaurant, at the same restaurant, Shauna is paid $2.70 plus $1.50 for each customers. So Shauna's wage, as you could see here in dollars, write a formula for Shauna. We're going to write a formula now for Shauna. So we're going to write W with S for Shauna. Shauna get $270 plus $1.50. Understand? Times M. Or so them say M customers. So you can't just put where you want to put in. Them say use M for Shauna, and we'll put the M and we're good to go. How is it going? Come on. Talk to me now, man. Talk to me now. Are we good? Are we good? All right, good. All right, so it's 1 mark. So that's what you would have put for your 1 mark here. 1 digga mark. Just 1 mark, not a big deal. Because based on the fact that they did theirs, they are saying that you can copy this easily. All right, now watch this now. In a certain week, Jenny and Shauna receive the same wage for serving the same number of customers. Hello? Yes, man. Same money to serve the same customer. How many customers did they each serve? Now, because we're going to serve the same number of customers, we are going to use the same letter because it's going to be the same number of customers. Because what a variable is, a variable is a letter that represents a number. Understand that. So when you're dealing with X and Y and A and B, they represent some number. You may not know what it is, but that's what it represents in algebra. So we're going to use a common letter for them. So let us say we're using N. Let's take a look. We're going to compare. This is Jenny, which is 600 plus 0.9 N. Now, I'm just saying what is. So we're stating the facts. This is Shauna, which would have been 270 plus $1.50 with the M. Now, in an effort to solve this, we understand that, hey, they said the same number of customers. So N is the same as M. I could use any one of these to solve the problem. I'm going to use N. So basically what we're saying is Jenny's salary is equal to Shauna's salary. Make we stop there. The M has to be N. See that? Same variable. Because there's no way you can solve with two different variables, same variable. That's why we said M and N will be the same number in the question. They serve the same number of customers. We call it N right now. Are we there?
Sir, what you would do, you'd carry the 270 over to the 600 and the 0.9 over to the 1.5.
Yes, or you can do anything you want. Just collect the ends on one side. So let us say we're collecting the ends on the left. So you're going to subtract 1.5 n from that, balance the equation. So you're solving a regular algebra equation, right? So I'm not rushing it, so I'm rewriting. Can somebody give me a nice number for that? Give me a nice number for this, even though it look like -0.6. Give me a number now. But then work with me. Or you want me to work it out myself? You work it out myself. You know? All right, make it
-0.6.
Yeah, man. So it's -0.6. All right. So this is -0.6 n, which is now equal to 270. And you're going to minus the 600 from both sides, balancing out the equation right there. So let us just rewrite. We're almost there. Almost there. What do we get? 270 minus 600. What's that? About -330.
Yes,
Then
sir.
330, sir.
They
Yeah,
divide both
negative
sides by
330.
-0.6. Divide both sides by -0.6.
Negative 55, 550, sorry.
So you get
550.
550. Conclusion that Jenny, we just conclude, Jenny and Shauna
Sir, 550.
must serve, yes, 550 customers. When you see what I go on? Look how much mark them give, 3. Because they must say a big thinking this. But just relax and ease yourself through. Come on, relax and ease yourself through. Any question?
No,
Sir, you have to write that in the information to tell them exactly what it is. Like when you write the Jenny and Shauna must serve.
Me love do it. Me don't know what to tell you, say, but me love do it.
Okay, okay.
Because I'm answering the question. I am
Okay,
answering
sir.
the question. So me
Okay,
love
sir. Okay, yes,
but,
sir. So
yeah,
just not just put down the answer. Give a wording something.
you can. CXC now go stop here, but because me I teach, this
Yes,
is a
sir.
teacher thing. You know what I
Okay,
mean? But
sir.
it's nice when you can write it. Like when it's a mark and you see. But between me and you, if CXC see this, them not let it up. But me love
Okay, sir.
conclude so and feel, close.
Okay, sir.
All right, let's keep running. Let's keep running. All right, so we're running into number 2. Number 2 is typically algebra. Sometimes it's some simple things, sometimes it's more difficult. This is factorization, typical number 2. As you could see, this is the difference of 2 square numbers. So basically, we're going to try to factorize this. Normally, this is 1 mark because there's nothing much going on here. So whenever you're factorizing the difference of 2 square, and when we say difference, you're subtracting 2 square things. You just open a bracket, man. And you put the square root of each. So 1 is the square root of 1. 4h square will give you 2h. And you repeat 1, 2h. And then you can just put a plus and a minus, or a minus and a plus. It's up to you. You put a plus and a minus, or a minus and a plus. You're good. All right? So good to go. 1 mark. Not a biggie. Are we good with that, everybody? This one is the difference of 2 squares. Let me know if we are all right. Come on. I believe we are good. I believe we are good.
Yes,
Believe we are good. All right. Yes. Go ahead. I'm listening. Somebody has a question. It sounds. Go ahead.
So difference of 2 squares when repeat what you say when it's a difference.
Let me show. Let me give more examples of a difference of 2 squares. The word difference means subtract. So subtracting 2 squares. A square minus b square. That's the format where that's a square number. That's a square number. Let me use a proper. That's a square term and another square term. Some of the square numbers are 1, 4, 9. You know them number here. You know them number here. These numbers will be popping out in this type of question. because these are square numbers. You notice 4 and 1 is there.
Mm-hmm.
And the h is raised to the second power, which is a square. So whenever you're subtracting 2 of these, all you have to do is to open your parentheses, and you're going to put the square root in the 2 brackets, the same things. You put a plus in one and put a minus in one.
Okay.
It sounds good now? Sound good now? Up and running?
Yes,
Perfect.
sir.
Perfect. Perfect. Now let's take a look at this other one. Let me write it. We have PQ minus Q squared minus 3P plus 3Q. We're factorizing this. Now, what you do quickly is to look if there is any common terms in each pair, because it's 4 terms. So you're going to group them. Whenever it's 4 terms, you group them. But while you're grouping, make sure that there is something in common for each. We're seeing Q for the first one and number 3 for the second one. So we're good. So we're going to factor out Q from the first one now. So you take out your Q. What you're going to do with this Q, you're going to divide it into these 2 terms at number 1. So when the Q cancel itself, you're left with P here. When Q take off Q to the second, you have minus Q. That's that. Then now what is common here is -3. Now the thing is, you would have to make sure that when you're doing the second bracket, the number that you take out here, when you divide it, it must produce something exactly like this. Now let's go. You divide this by -3, divide this by -3. When -3 goes into -3p, you're left with positive p. This -3 cancel, but it's going to be a -1q, which is just -q, right? Now that we have the same things in this bracket, that's when you know that you're normally finished. You're going to just, you could say you refactorize, or you could say for short, you just write back one of those twin brackets. Just write them back, p minus q. And you see the other 2 things, this and this, them come right here. So I'm just saying for short. All right? So you have p minus q, q minus 3. Or what if you wanted to put this one in front? You're good to go still. Doesn't matter. Any one of these you have, you get your full marks and you're gone. Any question pertaining to this? Are we good? Are we good?
Good, sir.
All right, sounding great like that. All right, make we go again now. Let's go again, man. Let's go again. Let's go again. Let's go again. Now, you may be required to solve here as well. It says solve each of the following question. What are we looking at? You're looking at 3/2y, which is equal to 12. You want to isolate the y. I could just show you one thing that you could do. There's a one step that you can do now, because you see, whenever I have a fraction that I want to get rid of, I multiply the fraction by its reciprocal. So if I multiply this fraction here by 2/3, you could see that it's going to cancel out fully. Look, 3 cancel itself, the 2 cancel itself. But whatever you do on one side, you have to do it to the other side. So we're going to have to multiply by 2/3 over here. Work it out and you're done. All right? Work it out and you see that you're finished. So a fraction, you just turn it upside down and multiply it by itself, and it cancels out fully. Balance the equation. So y is equal to 12 2's 24/3. Y is equal to 8. How does that look? How does that look, my friend?
Good, sir.
All right, so far so good. We don't have no problem yet. So far so good. We don't have no problem yet. Any question pertaining to that? Anybody?
No, sir. Sir, can you redo that one?
All right, what you want me to redo? This one? All right, we had 3/2y, and this is equal to 12. We want to solve for y. There are multiple ways to do it, to be honest. I was saying, this is a fraction. If you want to get rid of a fraction, you multiply it by its reciprocal. Flip it upside down. For example, 2/3. So you could see it flip, right? Multiply it by itself. 3 cancel 3, 1 time, gone. 2 cancel 2, 1 time, gone. But whatever you do on the left, you have to do the same thing on the right. you have to multiply this by 2/3. And we are saying 12 twos, 24 over 3, 8. Good to go. Good to go, good to go, good to go. That's regular, you know, regular working. Regular working, regular working, regular working. All right.
Thank you, sir.
Let's keep moving again. So we're looking at 2x squared plus 5x minus 3. This is equal to 0. We're solving. This is a quadratic. Normally with a quadratic, I check for factorization first. The last thing I do is the formula, to be honest. But it looks like it can factorize. So I'm going to take out my A, my B, and my C. What is A? A is 2. What is B? B is 5. And what is C? -3. I'm going to find AC right now. So AC is actually 2 times -3, and this is actually -6. Whenever you find AC, you're looking for the factor pairs that when you multiply, you get back AC, but when you add them, you get back your B value. All right? So I'm looking at the fact that I have 6 times 1 and 2 times 3. But because AC is negative, 1 must be positive, 1 must be negative. So I have to use 6 and 1. That's the only way I'm going to get a 5, because 1 is going to be positive, 1 is going to be negative. Let the bigger one take the sign of B. So B is positive, 6 is positive, this is negative. We're going to take these, and they're going to substitute where the middle term is. Let's rewrite. 2x squared. Instead of writing the 5x, I'm going to put positive 6x, negative x, or you could say negative 1x. So let me put the 1 there so people feel that it is safer. All right? Minus 3. And this is equal to 0. Now it is you realize that you have 4 terms on the left side, which means you could factorize this, then factorize that. My common factor is 2x. I'm going to take out 2x. I'm going to divide it into this. I'm left with x. I'm going to divide the 2x into this. I'm left with plus 3. Then I'm going to take -1. I'm going to divide it into this. I'm left with positive x. Divide it into this. I'm left with positive 3. This is equal to 0. Now, my common bracket is x plus 3. And then in the other bracket, it's going to be 2x with -1. Remember, we just spoke about this. And this is equal to 0. Remember the 0 product rule, that if 2 things multiply to give us 0, at this time, mathematically, we could say either x plus 3 is a 0, or 2x minus 1 is a 0. The 0 product rule said that, because the only time 2 or more things multiply to give us 0 is when some 0 is somewhere. Okay? So again, at this time now, we're going to solve. So for the first piece right here, let us subtract 3 from both sides. So x is equal to -3. That's one solution here. This one right here, we're going to add 1, balance the equation. So 2x is equal to 1. Divide both sides by 2. And as you could see, x is also equal to 1/2. My 2 solutions. All right. So x is equal to 1/2. X is equal to -3. And those are the solutions to that quadratic. There's a 2-mark question, not a big deal, but you got to handle that. I'll wait for any form of questioning relating to that. Any form of question relating to that, I'm here.
So, sir, you know, when to work this out, when you have the x squared, then the x, then the constant, you would work out the AC.
It's the same thing. What you can do if you get a question like that and you want to feel better, arrange it the way that you'll used to see. Do it. It's the same thing. You hear me?
Yes, sir.
Yeah,
So
man.
multiply
Arrange it to
AC,
suit yourself.
and so when you multiply AC, you would get AC
Alright.
is what would go in the middle to
All right, hold on. You want clarity on what you're asking me right now? Do you want clarity on that?
Yes, sir.
Do you have a particular question in mind so I could write it to express? Are you there? You have
Sir,
a
it's
particular.
just the AC when you're doing the
All right,
AC
hold
part
hold
and
on,
how
hold
to
on.
fit when to fill it in.
Yeah, man. I like to use examples and then see. All right. You want to use these same numbers and you do a thing with it and then we talk. That's what you want right now.
Yes, sir.
So to explain, all right. So you are gonna tell me what to write. So I'm gonna switch the screen. Tell me what to write. Okay? Tell me what to write. Say what you're saying by telling me what to write. I'm writing. Go ahead.
Sir, so we'll write out the equation
You
2x
still all right? Yes.
plus 5x minus 3 equals 0.
And you are
And
asking
then,
what now? Go ahead.
yeah, I'm saying like, so you would like write out what's A, B, and C, which would be, A would be 2,
Yeah, just like what we just did. Look a while, because we did
yes,
it.
B
We did.
equal,
Yeah,
and
man,
C
we do that.
equal 3. So AC would be, you would multiply A and C.
Yeah, man.
That number that you get, you would have to find numbers that you can add.
Factors of it. Factors. We call them factor pairs. Yes. 6 and 1 and 2 and 3. Factor pairs. Yeah.
And how you know when to put it in, fill it in
Okay.
into B? That's what.
Oh, that's what you're asking.
Yeah.
So watch this. First, you have to know all right. There's two type of AC you can have. You can have an AC that is negative, like in this case. AC can be positive. But you have to know the rules surrounding that. So this is a negative AC. When AC is negative, one of the number will be negative and one will be positive by law.
Yes,
All
sir.
right. So we are saying you have to keep in mind that these numbers, when you multiply them, they will give you back AC. But when you add those same numbers, they give you your B value. So you have to think carefully.
Yes, sir.
Exactly. So we are saying no, that when you find those numbers, so we realize that it's going to be 6 and 1. Because 1 will be negative. So it can't be 3 and 2. Because if one of those negative, you're going to go down to a 1. So this can't work. So we know it's going to be 6 and 1. And we are saying, let the bigger number take any sign B has. B is positive. So the 6 will be positive, the 1 will be negative. This is the check. 6 times negative 1. Look, negative 6.
Yes,
6 plus negative 1, positive 5. It's satisfied.
Oh, okay.
That is when you know that you could take it and put them right here and move on. Clarity given?
Yes, sir.
All right. All right. Let's keep moving. All right. Let's roll. Let's roll. Let's roll. All right. So we are at this part now. And it says the quantities F, M, U, and V, no, F, M, U, V, and T are related according to the formula. We're looking at the formula. All right. No, it says find the value of F when M is equal to this and so on. All right. So this is a simple substitution. Notice it's one single mark. You're going to substitute. So F is equal to M outside. What is M? 3. Open your bracket. V. What is V? 2. Minus U. What is U? Negative 1. Be careful. Negative 1. Let me put it like that so you could see it. All over T. What is T? 1. Make sense? Tell me if we have that. Now you're going to sort it out. Now inside the bracket, these two negatives will merge, become a positive. So what you really have is actually 3 times 3 over 1. So it's 3 times 3 over 1. So F is equal to 9. Let me know if you're good with F equal to 9 right about now. Everybody. F is equal to 9.
Yes, sir.
All right, all right, all right. So this is a simple substitution. One. Now they are saying, can you take this formula and make V the subject of the formula?
Sir, could you bring down the screen back a little bit?
So we're going to transpose for V after that. So after you write it off and everything. All right, all right, right. Let's roll now. Let's roll. All right, so we're
Okay.
going to transpose for V, right? Transposing for V. So let's write back the formula. So F is equal to M open bracket. This is V minus U, all right, over T. And we're going for V right here. First thing what you want to do is to get rid of the fraction. So you're going to multiply both sides by T, everybody. Multiply both sides by T. All right. All right, so you're going to clear it up now. So the T cancel on the right side. So instead of saying TF, I'm going to say FT, okay? So I'm going to say FT is equal to M, and we have this. This is what we have left. Remember now, what we want is V, and V is actually in the bracket. So you can see that V is in the bracket. So you're going to have to distribute the M inside. You're going to have to distribute the M inside to clear up things as you go. So FT is equal to MV. That's when you multiply M times V. Then minus MU. We're right there. Remember what we want. We want the V. So we're going to leave anything that is directly attached to the V for last. So we're not going to trouble the MV, but we're going to get rid of the minus MU by adding MU to both sides, right? So we're adding MU to both sides. So rewrite FT plus MU is equal to MV. We're almost done. To get the V by itself, M is multiplying to the V. So you're going to divide by M, divide by M. So finally, V is equal to FT plus MU over M. V is what we care about, and it's isolated. This is the answer. Anybody has anything that you want to say? Are we there? Are we good?
Yes,
Are we
sir.
good, everybody? Are we good? Are we good? Are we good? Are we good? All right.
Yes,
All right. That's another 9 marks. All right. Let us now jump into this is some, okay. Transformation. I think I'm going to put this on the other screen. So we might have, if you, like normally when I pick a question, as I say, if I pick some past paper, you're going to realize, say, you probably see most of the questions already, because that's how we work. As soon as we teach a topic, we now do the questions. I'm listening to you speak. I'm bringing this graph to the other screen.
For the exam tomorrow,
Yes, sir.
do our parents have to come with us to sign any documents if we go to a different school?
No. What you mean? You don't need a parents with you. You just need to go on with your ID. You don't need any parents with CXC.
Okay.
So also the dress code is changed, right?
No, you're good to go. You wear anything got the exam. Just mainly most schools would have said no sleeveless and cut up jeans. I know flip flop. I know flip flop. Them not too love them because to a business day, them kind of keep it business. So as long as you don't have a cut up jeans and flip flop and so, them good and sleeveless. Because some people have sleeveless problem. All right, let's keep it going. Let's see what the question says now, right? So the question says here, number one, that we're gonna state the coordinate of Q. Oh, this is very straightforward. The coordinate of Q. So you look, this is Q right here. Everybody, can we see Q right here? Can somebody just tell me what the coordinate is? Tell me what the coordinate is. That's all like Patrina. Tell me the coordinate.
4, 1.
4, 1. Right? This coordinate right here is 4, 1. So we're going to put it right here. So 4, 1. Everybody, straightforward. We have a.
So, sir, I'm not see. I am not sorry. I am not seeing the one.
What you mean by you not? I know you for write a one. Oh, you mean on the thing? No, man, they're going to do that a lot, Patrina. So you're going to look on this and you're supposed to say a 1. Make sense? They're going to do this a lot. Look at this. This is 0, and they skip, and then 2, then they skip, and then 3. Then out of natural, you're going to say 1, and then 3 is missing. You could see 5,
okay, sir.
-1, -3. So a lot of times they're going to do it, and you're going to have to just look and say, oh, and you fill in a little blanks now and then, right? You'll see what's going on. You'll see. All right, very good. Let's take a look at the other one. Now, it says here, the line P is mapped. Watch this. The line PQ is mapped onto P prime, Q prime by an enlargement. Center O, scale factor 3. All right. Draw P prime, Q prime. Now, one of the beautiful things with an enlargement, when you are enlarging from the center O and you have a scale factor, you can just multiply your coordinates. Multiply the coordinates by the scale factor and you're gone. So in other words then, scale factor is going to be 3. All right. So the coordinate, I'm just going to write this for you. The coordinate at Q, which is, so Q is 4, 1. All you have to do is to multiply these by 3. So your Q prime is going to be times 3 times 3.
Sir,
12.
so when there's a scale factor, as you said, all you have to do is multiply from the multiply to the.
Let me repeat it.
Okay, that you get me.
Let me repeat it. When the center is 0, 0, that's the most important thing.
Oh.
This only happens when the center is 0, 0. When you're enlarging and your center is 0, 0, yes, you can multiply the scale factor by the object coordinate to get the image coordinate. Only when the center is 0, 0. Are we there? So because they told us that the center is 0, 0, I am able to say, okay, Q is 4, 1. Q prime will be 3 times 4, 3 times 1. P, what is P? Is 2, 2. So P is 2, 2. So if you multiply this by 3, multiply this by 3, then P prime will be 6, 6. So we are going to plot 6, 6. 6, 6 is right here. This is P prime. And 12, 3 is right here. Let me put it back. 1, 3. And this is Q prime. And this is your enlargement. You can take your thing and you draw from here to here. There it is. P prime, Q prime. That's your enlargement. I'm listening to you speak.
Oh, you come by the 3, the 4 times 3 and the 3 times 1.
Oh, I come by the, repeat.
Oh, you come by that, you say 4 times 3 is 12 and 3 1.
Yeah, man, but when you say that, when you say, oh, I come by that, what do you mean by that? I want to be clear.
The 3, sir, where the 3 come from?
It was given to you. It was given to you. It was given to you in the question. Look.
Okay.
This is the question. Okay. That's why I was saying I want to hear what you're saying. It was given. Look. The center is 0, 0. Scale factor is 3. Okay, so we are saying, and when you say the scale factor is 3, the thing will be magnified 3 times bigger than what it was. That's what it means. All right. All right.
One moment, sir.
All right. Everybody, any question pertaining to this? Are we good? We seeing what's going on? Yeah?
Yes, sir.
All right. All right. Make we see if we can see what else they're asking. Hilton, you're good? Let's jump on the third now.
Yes, sir.
It says the triangle, this means triangle, the triangle OPQ undergoes a reflection in the line y equals 0. Anybody knows another name for y equals 0? Another name, please. Another name. Y equals 0. All right. Going once, going twice.
I guess that's the x-axis.
It is the x-axis. Don't guess. Please don't guess, Miss Hilton. It is the x-axis. So y equal x is the x-axis. So basically, no, y equals 0 is the x-axis. So basically what they're saying is there is a reflection in the x-axis, but they can say it this way as well. So we want to be very aware of that. Okay. So what we're going to do now is we're going to reflect the original thing in the x-axis, and we're going to name it O double prime, P double prime, Q double prime. All right. So let's go for it and then reflect it. Let's go for it. Here it is. So we're going to reflect it in the x-axis. Let me see if I can get some size on this diagram here for you. Pull it across a little bit right here. Right here. All right. There it is. There it is. This is big enough. All right. So right here now, what we're going to do is, remember though, when you're reflecting, right, in the x-axis, I'm going to draw the mirror. Ready for your mirror line? This is your mirror. That's your mirror line. So we normally label it. This is our y equals 0, aka x-axis. Now the point O is in the mirror. And imagine if you're standing inside the mirror, you won't reflect anywhere. Makes sense? But P is 1, 2 units on top of the mirror. It's going to flip 1, 2 units below the mirror. So this is going to be P prime prime. And remember, we have O prime prime right there in the same place. Q is 1 unit on top. It's going to fall 1 unit below. So this becomes Q prime prime. All we have to do now is to recreate our shape. You take a nice ruler and you're going to draw your thing. Do not use a free hand. Draw your thing and let it look nice, like how mine are going to look. All right, I might use blue. Allow me to use blue. Switch it to blue. Use a ruler and make sure it look good, nice, and easy, at ease. There it is. And you could see that reflection right there coming out, right there, right? Everybody, any question? Are we good? Are we okay? Question asked, anybody? Are we okay right there?
Yes, sir.
Sir.
Yes, sir.
All right, all right. Everybody like up the video now. Like up the video, please. Like up. When I like up the video yet? In the class, me don't have the phone, man. Like up the video and make it think flow. All right. It's done. So you see, the exams are really, the exam are fun still, you know. I don't know if this is fun, but.
Wait, sir, I think we forget some.
What you want to ask?
Where is it, OPQ undergoes a reflection.
What you say you forget?
Yeah, we forget how to do that part there, sir.
Oh, reflection?
Yes,
count.
sir.
A reflection, you count. I was counting, you know. Did you leave the class just now?
Yes, sir, mother did call me.
There, you have to go watch it live, brother. You have to go watch it over the live, man. Come here and say, everybody see where we are count. We spend time on count. We can't count over right now, you know. I count your count to the, all right. It's distance. Let me just do it quickly. Look, P, it's 1, 2 unit on top. That means it's going to fall 1, 2 unit below. Make sense? Yeah?
Yes, sir.
Yeah, man, and Q is 1 unit on top. It's going to fall 1 unit below. How would it say? Lily?
Yes, sir.
Tell Cecile to stop stressing out now, man. Huh? All right. Ready to go again, class?
Sir, so wherever the line is, wherever they tell you the line is, that's the same concept you're going to use.
All right, you have to speak more clearly, understand what you asked me. Which line you're referring to? Talk to me straight.
They said y equal O.
No,
that's the line that you use?
No, man. And a y equal O. It's not y equal O. This is y equals 0. It's not O.
Yeah, 0.
Yes. And I'm saying to you, y equals 0 is the x-axis.
The x-axis, yeah.
Also, go on the y-axis and look. Watch. I'm going to clear it up for you now. So I'm going to mess up what we just open the arrow to that. I mess it up now. Look for yourself. So I'm trying to show you something. On the y-axis, just for clarity, for you to understand. Because you ask the question, so you need the clarity. So on the y-axis now, go on the y-axis. I'm going there. This is when y is 6. You go across to infinity. Make sense? This is when y is 4. Make sense?
Yes, sir.
This is when y is 2. Make sense? Yeah. And then look now, this is when y is 0. Which axis is this? The x-axis?
X-axis, yeah.
Exactly. So it's another name for it. It's not a biggie. All right?
Okay.
All right.
Sir,
and then,
I guess...
yes, I'm listening. Speak. I'm listening to you.
No, go ahead, because it's not pertaining to...
Yeah, I was just saying, and the flip for that is x equals 0 becomes y-axis. You just look, you'll see. All right?
Sir, I was saying that you should check your YouTube comment section.
Oh, yeah, me do it sometimes when me asking for chill. Me do it sometimes, but me can't respond to everything. All right, you mean the people that discuss marks and 70 are grade 2 and then...
Sir, yeah, and somebody has say, it's not fun because they don't know what they might do.
Okay, let me get oh, let me get you. Yeah, man. Yeah, man. I say go. When you go class and study all year, you know what you have to, but when you don't, then you don't. I just say, all right. It says the function f with the domain A is this. So watch this. They tell you what the domain is. In other words, these are the x values that you're supposed to use for this question. Only 1, 2, and 3. You understand? No, it's given by this function. What is f1? Everybody, f of 1 means that you're going to substitute 1 where x is in the f function. Hence, half x minus 3 becomes half times 1 minus 3. This is a half minus 3, which is going to give you minus 2 and a half. Tell me if you're all right with that. Tell me if you're all right with that. Talk to me. Half minus 3, no, I'm not going because you have a half of a. All right, all right. Regular, 1 mark. 1 mark. But then go on. It says, find the value of x for which.
Yeah, so why
Find the
not
value.
too much, no man, 1, 2, 3, 9 bracket.
Oh, let me read it again. You have to read. It says the function f is given by domain. We already spoke of domain. Domain would be the values on your x-axis that they plan to use in a disamatia right now. That's all it means. Domain is your x values that you will be using when you are complete the table and you say x and you say y and then tell us some number. You know, just regular. Don't overthink it. They are telling you that these are the x values. Domain mean x values. That's why I said it very early. These are the x values that will be used in this math that we're doing at number 4 only. That's all. There's nothing else to it. Those are the set of x values that they'll be using. They'll be using 1, 2, and 3. So they use 1 look a while, so them tell you if you find that. And when they do it, you get that. Next, they are saying, find the value of x for which f of x equal negative 2. So f of x is this. You want to know what value could come where x is, and when you're done working it out, you get negative 2. We already discussed this in functions that all you have to do is to take the f function and let it equal to negative 2, then solve. Because you're saying, I don't know what it is that caused this, but I intend to find out. So let it equal to it, then do it. So now you will add your 3 to both sides. So a half x is equal to positive 1. You need x by itself, so you multiply both sides by 2. So you could see on the left side, x is now equal to 2. This is another number from your domain. Remember, them say them are going to use 1, 2, and 3. Everybody agree? See, number 2 come out x equal number 2. In other words, when in this function, let me just tell you what this is saying. In this function, when you put 2 here, so the result becomes negative 2. That's what they're saying. Sorry. F of 2 will give you negative 2. So that's that. The answer for that question there is 2. All right? Let me take off this. All right. Keep going. So the question says...
Sorry, I can't bring down that because that don't look right to me. 1 month, let me just take the picture.
No, man, ask a question. Remember, say we there saying, ask the question where you ask. No matter.
Sir, all right. So with the remember say a negative 2 we are fine, right? So in where the x would be, you'd put the negative 2 there, sir, right?
No, man. That's why I say you ask the question. You are doing this. That's not what the question is. Look at the difference. What you ask me is this, but that's not the question. These are two different questions. Look, you just asked for f of -2, right?
Yes, sir.
They didn't ask about that. They are saying f of x must result in -2, meaning,
Oh.
okay, I think we need to say it. In other words, some random number goes in the f function, shake up and turn around, and you throw out -2 when it's done. We are trying to find what number went in to cause that. We found out that x is 2, and when it goes in, all right, in other words, I'm work it out for you. Look, half times 2 minus 3. All right, that's it. Half x, right? So now do it. So half, so 2 cancel 2, so you have 1 minus 3 is -2. That's what they're saying. When 2 goes in as an input, the output is -2. This is output, remember, you can't mix up these, this is output. And they're asking, what is the input that went in? And we are saying, the way to do it is to solve the equation, man. Let the f function equal to the output and find a way to find the input by using algebra. Okay? That's what we did and find it. Man, in there, wait for something for you. You have to say something. Manning? All right, Manning looked like she gone. If Manning gone, we're gone too. All right, next question. Now, for the next question, it says here, an ordered pair for the function is expressed as this. This is how you express ordered pair anyway. Same thing as x, y, okay? Using your answer from above, which is the ones that we have been using, or otherwise, list the ordered pairs for the function f. Let me say this to you. Go back up here, so. F of 1 give -2.5. I'm going to write it down for you now. Something I'm going to show you. 1 gives -2.5. Let me write it down for you. Something I'll show you. When 1 went in, -2.5 came out. I'm just going to write down so you could see what you have. When 2 went in and -2 it produced, that's what we just did right here. Remember, they did tell us that the domain that they're using, the x values they are using would be 1, 2, and 3.
Yeah, they're just putting in what went in and then what came out, the output.
Yeah, man. Remember say x and y, them, input a x and whatever come out a y. Remember, we say it from not now, for you learn. From you were learning, input is x, the result of it is an output is a y. So when you find f of 1, the result is a y value. Yes. So we are saying here, we have 2 pair already. We need the last one because we don't know what goes on for 3. We have to take up 3. You're going to have to take up 3 and put in the function to know what will be the result. Remember, it's half x minus 3. And you're going to put 3 in the function here to find out what you get for 3 because we don't have the y value for this yet. All right? So this is 3 over 2 minus 3. Everybody agree? So 3 over 2 is 1.5. So let me just write it 1.5 if you want to look at it like this. Or what 1.5 minus 3 is -1.5. All right? Or you can write it as -1.5. And you want to write it. I'm just saying. Or you can write it as -3 over 2. Same thing. Same thing. Same thing. All right? So you could put negative, I'm going to put -1.5 here. So in other words then, they had told you what their domain is. 1, 2, and 3. And domain refers to x value. See them here? 1, 2, 3. And they wanted us to write the coordinates that it would produce when you were playing with this function. This is the function. You're substituting the x values here to see what you get. And you're only using number 1, number 2, number 3. Number 1, number 2, number 3. Not a big deal. Relax yourself, go through. Don't overthink it, don't overshoot it. All right, let's roll the ball. Let's roll the ball. So those are the coordinates that we have. All right. All right, good. Now look at this question now. They said explain why f of x cannot equal to 5. All right, so they are saying explain why it cannot equal to 5. All right, explain why it cannot equal to 5. Now, all you're going to do is to remember your f of x is equal to this. The context for their question now is your domain. Your domain can only be number 1, number 2, number 3. Domain refers to your x values. This question told us that these are the x values that we're going to be using to solve any problem for number 4. 1, 2, and 3. They are saying, tell us why it could be number 5. So look, f of x. So we're going to put number 5 there. We're going to let the f function be 5 to find what x value produced that, to see if that x value fall within the right context. In other words, if it is not 1, 2, or 3, that is the reason why 5 can't be a part of the whole thing. Let's work it out. So you're going to solve this to find the x now. You add your 3, add your 3. Half x is equal to 8. Then to solve for x, you're going to multiply both sides by 2. X is equal to 16. 16, you know what I say? X is equal to 16. 16 is outside of the given domain. You hear me I say? Them tell me say 1, 2, and 3 alone can be the domain, the x values. And this is telling me that for f of x to produce 5, we must use 16. But 16 is not a part of the game. That's why it cannot be 5. 16 is outside of the domain. Therefore, f of x cannot equal to 5. Me just say, me just do it and talk and explain so you can see what I say. They told us that is only number 1, number 2, and number 3 you can use as an x value. So when you work out anything and did not get 1, 2, or 3 as x, those are not valid for this question right now. All right, you can always go back on the live and go look and think about it, but we're rolling like a dice. We are in the B part of this question. We're going to solve an inequality. Remember the context of solving an inequality. It is solved just like an equation. So it says solve 3x minus 1 less than 11. Approach it just like you approach an equation. You're going to add 1 to both sides. So 3x is less than 12. Then you divide both sides by 3. X is less than 4. Now, x is less than 4 is the solution right there. Done. It's 1 mark, so you notice it's not a big deal. So they are saying, all right, not too bad. 1 mark. Let's see what the next question is. So this question now,
Wait,
similar.
so you can go up just for a second, please. Oh, okay.
You want to ask that question? Are you good?
No, I just wanted to see if it was what I got when I.
All right. Good, good, good. All right. You got it?
Yes, sir.
All right. Very good. Now, let's take a look at this. We're solving. We're going to leave our x right here. Leave it. We're not going to trouble that. So we're going to add 1. Let me rewrite this so it looks bigger. So we're solving for x. We're going to add 1 to both sides. Yeah. So on the left side, we'll have 3 less than or equal to now 3x, because negative 1 plus 1 is 0. What I'm going to do now, I'm going to divide both sides by 3 so I could isolate my x. So on the left side, we have our x. It's 3 into 3 is 1. Now, please read from where the variable is. x is greater than or equal to 1. So if you want to turn it around and feel better, you know, you can turn it around and say x is greater than or equal to 1. It's up to you. Understand? Now, this is the answer for 1 mark. So it's not a lot, right? Because they're expecting you to just, you know, quickly match up that. Now, the other part of the question says, represent the solution. All right? So you represented the solution for the two things combined, you know, on the number line. Remember, you know, it's 2 parts to the game, you know. Remember that it's 2 parts. Watch this. Let's write it down. One of them say x is greater than or equal to 1. And the first part, look at this. Look at this part to the game. Remember, I said we just did this part to the game upstairs, right? That's all. And we get x is less than 4. So the same x is less than 4. X is less than 4. So what they did, they gave you 2 separate things that and then combine them here. See here? See one of the maths here, the way you just do, and see the other maths the way you do before. No problem, man. No problem. Now they want you to represent this on the number line. Now, look at it. If you should combine your idea, you know, think about it. X is less than 4. But that same x is greater than or equal to 1. I just combined the 2 things. Take a look at it. X is less than 4. But that same x is greater than or equal to 1. Now remember, whenever there is a bar underneath your inequality, you are going to shade that spot. Yeah? And whenever there is no bar, you're going to leave it open. So at positive 1, it's going to be a shaded thing. And at 4, you're going to open it, not going to shade it, and then you draw a line connecting them. That's it. That's it. So this is saying to us that x is less than 4, but greater than or equal to 1. 2 marks for that. Any question? Anybody want to ask? You could ask it.
Sir,
Go
can
ahead,
you
I'm
read that
listening.
one more time, please?
Yeah, man. Ask the question where you ask. So me answer your question.
Sir, where the 4 come from?
Me not that, yes. Like
The four, all right. Remember, say, look at this. Manning, say this for me. Say this. Just say it for me to say it, because that's something why I want you to say it. 3x minus 1 less than 11, right?
Yes,
What was the
sir.
answer for that? Now, eat this.
Oh, sir, that's where the 4 come from. So you just use it on the
I don't
thing
just
down
use it.
there.
That them tell if you use it. No, man. Look on the question. That's why I said, look at this. I asked you to say it for a reason. 3x minus 1 less than 11. Now, eat this. 3x minus 1 less than 11. Now, eat this.
Oh, yes, sir.
For this part, x was less than 4. And for this part, x was greater than or equal to 1. You see it now?
Yes, sir.
Exactly.
Oh,
Hold
Sir,
on.
maybe because through the 2 of them kind of look like it's in a 1.
It is in 1. It's
it
called
look-
compound inequality now.
Yes.
So what they did, I said it, like what they did is they gave you 2 separate inequality and then they combined the idea and then I wrote it right here. Remember saying me right so right and I said then combine it. So I want you look out at your eye for these little stuff. Look, because you just do this, you know, you must remember say you just do the part here. And you must remember say you just do this. See the right pan top? Yeah, man. Everybody good now? That's where the 4 and the 1 come from. It's the same question, you never done. A, B, and you know? Are we
Sir,
good? Go ahead, I'm listening to you.
sir, the 3 cancel the 3. It could be 0.
Where are you referring to? When you say 3 cancel 3, where are you referring to? Where?
Sir, the 3
It divided
less than
up.
or greater than.
Yeah, man, but 3 divide by 3 is 1. It's not subtract or so. It's divide, right? 3 divide by 3 is 1, right? Agree?
Sir, what you say about
Wait.
it? Circle them on the line.
Wait a minute. Let me talk to the person first. Person with the axe. You see what I'm saying right there? 3 divide by 3. That's 1.
Yes, sir.
All right. Now, let me go back to this. If your inequality has a bar underneath it like this, and you're required to represent it on the number line, you have to use a shaded circle.
Oh, so
If
that's
your inequality has equal in it, you have to do this. This suggests that this is a part of the solution. If your inequality does not carry any bar, like it is just greater than or less than alone, you use an open. There is no shading for that. I hope you get that
okay.
now. So,
Yes, sir.
good. All right. All right, let's move again. All right, done. Number 5.
Excuse me, sir.
Yes, sir. Go ahead.
When would you change the number to a negative number when dealing with inequalities?
When you change it, are you asking me, is there a time when you can when you have to flip your sign? Is that what you want to ask me?
Oh, yes, sir. Yes, sir.
Think of that you want to ask. All right. We could take a moment for learning. So it's not a question from the question, but it's a question for the exam. I'm going to demonstrate what Todd was asking. Todd was asking this. What if we have negative 2x plus 1 greater than anything, 5? Now, everybody, this is not a part of the questions that we have. It's just something that we need to make note of. So you would have been solving this ordinarily, okay? So you would have subtracted 1 from both sides. This is normal. There's nothing going to happen to your inequality. The only time your inequality will flip is when you multiply or divide by a negative number. Let me repeat. The only time your inequality flip is when you multiply or divide by a negative number, like what we're about to do now. We're about to divide by a negative 2. Because you divide by a negative 2, okay? X is now greater. You have to flip the sign. That's what, when you divide by a negative, it does. That's the only time you do something. If you divide or multiply by a negative number, flip your sign. This is what you're asking, Todd.
Oh, so when it's a positive number, you would keep the sign how it was?
Yeah. That's what I'm saying. Everything is normal. Ignore everything. It's normal. The only time you're going to do something different is if you have to multiply or divide by a negative number. That's when you turn around the sign. Everything else is normal. That's the best way to look at it. Everything is normal. It is only abnormal when you're going to do this, and then you turn around the sign. That's what we're saying. Are we good? Talk to me, man.
Yes, sir.
Yes, sir.
Huh? All right.
Yes, sir.
All right. Make we keep rolling now. We could keep rolling because if we continue, we're not going to finish. You know? All right. All right. So here it is now. It says the students in the group were asked to name their favorite sport. The responses are, it's in a pie chart. You're looking at it. All right, let's go. So the first question says, calculate the value of x. So if you want to calculate the value of x right here, you have to understand that, hey, this is a full circle, right? That's a full circle. And with that full circle, we have everything except x degrees. So a full circle is actually 360 degrees. We're going to take out the sum of the 94 plus the 45. So you're going to add 94 plus 45. And you take it.
139.
How much I get?
139 I got some. Then 20 minus that.
When you add them, you get 139. That's what you're saying. And then when you subtract, what you get?
221.
All right. When you do it now, the answer is 221. It means over here is 221 degrees. Are we there? Everybody, are we good?
Yes, sir.
All right. Not too bad. It says a 1-mark question. Now it says now, what percentage of the student chose cricket? Percentage. Go back to the cricket. What is the angle for cricket? Everybody? 94, right?
Yes.
Are we there?
Yes,
So
sir.
94 out of what? What's the total degree for one circle?
360.
So this must be represented as a fraction where cricket is 94 out of the 360. So this fraction must be turned into percentage. And when you're turning anything to percentage, you simply multiply by 100. How does that sound? How does that sound?
That's
So all you have to do is
26%.
put this on your calculator and tell me what you get. What you just said?
26%.
The 1.11. Don't play with it.
Right.
Don't play with it.
Okay.
Don't play with it. No, don't play with it. This is so serious. Don't play with it. Don't put 26. Put 26.11. Okay? Don't just put 26.
Okay.
We don't fancy old number like that. All right? 26.11.
So they really would have given me a mark because I put
Yes, they really wouldn't give you. Worst case scenario, three significant figure. 26.1. 3 significant figure. Let's tell you. Whole number don't mean nothing to nobody, and it will be too far from the truth. 26 is nowhere near 26.11, okay? All right. So anyways, so don't just do that. Do what we have to put on screen. Let's go for the next question. All right. So the next question says, given that 40 students chose tennis, calculate the total number of students in the group. Now watch this. Them say 40 students, 40 students chose tennis. 40 of them choose tennis. Now let's see what goes on for tennis. Tennis is actually 45 degrees. Tennis is 45 degrees. All right? Tennis is 45 degrees. There are multiple ways to do this. So they want to know the total number of persons in the group. There are multiple ways to do it because you can say 40 students. All right. Hold on. Tennis is 45. I'm going to put 45 here. Just to remind yourself, it's 45 degrees. Now, remember now, there are multiple ways to get there, okay? So you can approach it from a degree standpoint where 45 degrees is 40 students. I'm just saying. Therefore, 1 degree, the reason why I'm doing it like this is because you're kind of used to this. 1 degree is to take the 40 and divide it by 45. That's 1 degree. All right, and you're going to get some, what, 0.888 something?
Yes, sir. 0.8888.
All right, so you get 0.88, you can't stop. All right. Now, this is 1 degree, you know. So that means to go 360 for the whole thing now, the entire thing is to go 360. This is one way to do it, because you could use percentage too. So you'll multiply this by 360, because you're moving from 1 degree to 360 degrees. This is just one way to do the problem. I'm not saying you have to do it this way. And it's going to turn out into 320 students. And if I had the time, I could use percentage and do it another way. I just don't have the time. All right? Again, you will understand that total here, if you're using a circle, is 360 degrees. I'm just saying. So what you could do is to take that 45 degree, apply your ratio idea, find 1 degree, and turn your 1 degree into 360 degrees. It's going to work out for you, I'm telling you. And if you had done it another way with percentage, it's still going to give you that 360 using percentage, all right? But we're good to go, so we're going to just move it. 320 person in total is there altogether. Anybody with a question? Or we just go and scroll? All right.
No, sir.
Scroll. We just go and scroll. Scroll. Hold on. Well, it look like something missing from this. All right, this is it. All right, make we see what I want. What's this? Was that an A? It look like a piece of my question. Oh, I'm a question. All right. All right. Next one. It's a B. It says here, the diagram below shows the frequency polygon. Okay. frequency polygon. So it says of a number, watch this, of the number of goals scored by a football team in 25 matches. You see, I have to pay attention. 25 matches, key goal score. So you're looking on the y-axis, number of matches, and then the goal scores are here. All right, so pay attention to the details. Now we're going to use this to answer question. Question, it says complete this. So you're going to complete this. Complete it, man. Number of goals, 2. Number of goals, 2. Match with 3. Make sense? Everybody?
Yes,
Everybody
sir.
see that? 5.
Yes, sir.
Goals are 5. Number of matches, 2.
Yes, sir.
Simply go across, pick up. Not a big deal. Not a big deal. So you're just simply reading coordinates, you pick up and you're gone. You complete it, they normally give a 1 mark for that, as you could see. Not a lot of marks, and you just keep rolling. Now it says, what is the modal number of goals scored? This normally catch people in a table like this. Remember now, your frequency, all right? Your frequency is not the answer. Your frequency will help you to find the goals. So the question is the modal number of goals. You're going to focus on the frequency and use it to tell you. The greatest frequency will tell that number of goals scored. Can anybody tell me the greatest frequency? In other words, you go for the F row, F, and look for the biggest number where F there. Yes, it's 7, right?
7.
And that's not the answer to the question now, because 7 is how many matches had this many goals. What was the number of goals in these many matches? What was the number of goals? 1. 1. So in other words then, 7 matches are 1 goal scored at the match. And that it has said. So the modal number of goals scored by a team is 1. 1. Tell me if you're not good with that. Please. Are we good with this?
Yes, sir.
Yes, yes,
Yes,
sir.
sir.
See me here. What
But
if
the
I people put 7?
frequency helps to find the
Yes,
final answer.
ma'am.
That's all.
Yes.
Okay.
Yes. All right. You know, so your frequency is never an answer, because your frequency is not even there. Your frequency is not even there, to be honest. And we write frequency. Let me tell you why. Match 1, 1-0. Match 2, 1-0. Match 3, 1-0. 1-0. 1-0. 1, 2, 3, 4. You realize 7 is not a part of your stats. At 1 goal, you record 7 times. So this is telling us how many times we saw this certain goal scored. You get what we're saying now? 7 is not even in your stats, any at all. You understand? 7 goals not scored none at all. So if them ask for the modal number of goals, not 7 goals are there. 7 was how many matches it occurred in. So I mean, just look out for this, because we can tell it trick people every time. Them just pick a wrong number. Determine the median number of goals scored. Again, your frequency will help you to find the median. So we are talking about frequency will help you to find the median. Allow me to remind us of how we find the median. First things first, we need to know the total frequency. Let's add them up. 5 plus 2, this is 15. 17. This look like 20. Did they tell us it was 20? I don't remember. Did they say 20 matches or 25? It's 25. Check up and tell me how much should I get. Let me see, 15. This look like 25, man. 6. Yeah, man. 20. Hold on. Let me check it out. Double check this with me. 12.
25.
Yes, sir. 25.
25. All right. Thank you. 25. 25. All right. Yeah, man. 12, 15, 18, 20, 25. So we have 25. So when you're going fine, we're going to stay right as and do. No, we normally just do this. It's me just say frequency plus 1 divided by 2. In other words, then 25 plus 1 divided by 2. So that is basically 26 divided by 2 is 13. So I am looking for 13 to help me to decide where the middle is. Let me go again. I'm going to do a cumulative check on my frequency going in 2 separate directions. And I'm going to check for 13 as I add. Watch. So frequency, I'm going this way. 5 plus 7 is 12. Me not reach 13 yet. You see, by me add 3 more, me pass 13. Look again. 5 plus 7 is 12 plus 3. Me pass 13, so me stop. So when I'm going this way, it's telling me that this is my median. But I'm going to have to check it, go the other way. Let me change the marker to go the other direction. So I'm starting where 1 is, 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 3 is 10. Me not reach 13 yet. And then 10 plus 3, 13. Me reach, me stop. So both of them were telling me that number 2 is the median. So you have to do a cumulative check. Go both directions. Sometimes you will get 2 different numbers. When you get 2 different numbers, you add them and divide by 2. When you get one number, like in this case, you take it and you're gone. The answer is 2. The median is 2. The middle term is 2. Is that clear?
The formula that you said you used to find it again.
This is just a simple thing that we use to find the position of the median. It helps you to find the position of the median. And this is, we only use this when we have data organized in a table already. Because when you have raw data, you line them up and count and find the middle. But when it's already organized in a table, this is the most efficient way to find it. Because suppose you have 200 things, you can't line up 200. You just say 200 plus 1, 201, and you work and you find the position. So this helps you to find the position of the median. All right? Position of the median. It's not the median. All right. All right, all right. Sounding good. All right, sounding good. All right. Calculate the mean. I'm going to have to go up. So I'm going to write the formula for the mean right here. Everybody, the mean is the sum of the fx over the sum of f. CXC will not give you that formula. You must remember it, okay? Let's go back to the table now. So we're going to have to create a fx row because, so I'm going to put fx here. See f, everybody see f here, so for f, and you see x this already. So we're going to do fx, and it means f times x. Let me clear up the table now. I'm going to clear it up. So we're going to do f times x, everybody. F times x, so you're going to say 5 times 0 is 0. We don't want that. All right? And then 1 times 7 is 7. 3 times 2 is 6. 3 times 3, 9. 4 times 4 is 16. 2 times 5 is 10. 1 times 6 is 6. And then you're going to add up all of these numbers. Somebody add it up for me, please. Add up all of these. Come on, let's go. Add them up. 7 plus 6 plus 9 plus 16 plus 10 plus 6. Looks like about 54 to me. I'm getting 54 right here.
Yes, sir.
All right. So we have 54 and 25 to work with, right? So now go back down there. Our sum of our fx is 54. So right here, we're talking about having 54 over 25. Whatever you get, that's the answer. Don't be afraid of the answer. We are getting 2.16.
2.16.
Very good. 2.16 goals and average. All right, that's what we're dealing with. Are we there? Are we good?
Yes, sir.
Yes, sir.
All right, all right. Make we roll the dice. Make we roll the dice. You realize the question done? Question done. So sometimes that's how it comes. All right. So
you divide something by a while ago.
The formula to find mean is to find an fx column where you multiply the frequency times the scores, and then total them. Yes, and then you divide that by the total frequency.
Oh, the total.
F is for frequency all the time on statistics. All right. Everybody, we good? Talk to me now, man. We good? Remember, I said tomorrow I cook the exam tomorrow, you know. Remember, you know. Everybody, so number 5 was a statistics question. Number 6, measurement question. It says in the question, take the value of pi to be 22 over 7. Follow the people and instruction, please. It says, the diagram below, not drawn to scale, shows a cross-section of a circular metal disc of radius 21. A square hole with a side of 6 millimeter is located in the center of the disc. We are looking at that. So the question says, number 1, calculate the circumference of the disc. Circumference is the distance along the boundary, man. We want to find this. Hello, we are looking for this. Hello, that distance can be found by a formula that is given to you by CXC. So you don't have to stress out about this. Circumference, CXC say it's equal to 2 pi r or pi times diameter. Okay, but I'm just going to stick with 2 pi r now because we get radius. So it's going to be 2 times pi, CXC say use 22/7, times radius 21. All right. So now let's work this out. 2 times 22 times 21. I normally love to work out my maths, all right? So I get 924. And if I divide that by 7, I believe the answer will come now. Divide it by 7, we get 132 millimeter. Remember the context. Talk to me now. Just a simple formula we put in, no big deal. It's just a meal deal. Come on, let's go. Come on, let's go. Come on, let's go. Come on.
So scroll up, Mr. Circle again.
Sure.
I'm listening to you. I'm Ragisha. Go ahead with your question.
So I would just put 132.
We can't answer the question there. You're supposed to put your unit. You understand? We can't answer. Why you not leave it off though? Why you not leave it off though? That's the question. Don't leave it off. I'm going to say don't leave it off, man. Come on, man. So I don't like Ragisha, we're not planning to make mistake, you know? So
Why I want to use the 6?
Talk to me. Why you all right? Good question. The question that you're doing is asking you for the distance along the boundary of the circle. This has nothing to do with the boundary of the circle. How does that sound?
Oh, yes, sir.
All right. Come on, any question you want to ask, it doesn't matter. We're ready. Answers waiting. All right, let's jump on to the next one. It says here, the area, watch this now. This is time for what you want now. The area in millimeters square, square millimeter, of the cross section. Let's take a look at it again. So the cross section basically is going to be the area of the circle, and you're going to have to cut out this because this is an empty gap in the center. So there's a square hole in the center of the disc. Okay, so you're going to find the area of the circle first. Remember the radius of this is 21. All right, so let us write something that represents the cross section. Eh? So I'm going to say area of cross section. Area of cross section is equal to the area of the disc minus the area of the square. Make sense?
Sorry, I have to write them something there.
Why wouldn't you?
No, let's just ask.
Why wouldn't you? Because the question is, would you think about it? The time you take to think about it, write it. I am thinking about it and I'm writing it on screen. This is how I would write my exam paper. All right, let me help you. You see everything what you see me I do, I summarize paper. I know. If I'm thinking it, why not write it? I think about write it, man. You give direction and it make less error. No, you know. Between me and you know. Now, isn't this you're going to execute? Isn't this that you're going to execute?
Yes, sir. That's why may I ask you if you have
that's why you have to write it. Why would you want to write what you're about to execute? This allow you to make less errors. I'm telling you. Because when you don't write out the thing properly, you're going to make mistake. Write it out. And every single maths teacher, every YouTube you watch, they're going to do it. You understand? And we are teaching to do the right thing. This is not about rushing. Okay? But rather you take your time and do 2 questions proper, then you rush and everything all over the place and you don't get nothing right. Slow down. Write where you're right, man. And go through. It work out. Anyways, so the first thing that we're about to find we're going to find the area. So I'm going to find the area of the disk. So we're going to just relax, area of disk. Everybody agree? Area of the disk is going to equal to pi r squared. Pi is given as 22/7 times the radius, and the radius is 21 times 21. So everybody, you could work out this. You could just put this on your calculator. 22 times 21 times 21. Tell me what you get. Divide that by 7. And relax. So you get 1,386 square millimeters. This is the area of the disk. Let us go for the area of the square next. This is going to equal to length times length. Remember though, that is 6 times 6, which is 36 mm squared. Finally, the cross section. We already stated that it's going to be the area of the disk minus the square, and it's going to be 1350 mm squared. Are we there? Are we there?
Yes, sir.
Good to go. Good to go. Hilton, more than one time you asked me the same question. You asked in a class about 10 times already.
Sir, I never asked you that yet.
You asked.
I just think about it, because I say, well, if I write it that, man.
Yes, it is. And that's why I get 2 hours and 40 minutes. So almost 3 hours in the exam. When you go in 9 o'clock, about 12 o'clock, you come out. Think about that. I won't leave a time that. All right. The next question. It says, given that the thickness of the disk is 2 millimeter, right? Watch this now. Watch this. Hold on. Let me drop me this. I may have a little square thing here, so. And then they say the thickness is 2 millimeters. See there? And this. Boom. Everybody see me this now. When I like it, tell me if you don't like the distance. Quick and fast. So at this, that's what it really looks like. So it says, given that the thickness of the disk, so you see the little piece here? That's the 2 millimeter that I talk about, right? So the thickness is 2 millimeter, right? Calculate the maximum number of disk, right? That can be constructed from this. From this. In other words, you need to know the volume of the disk first, because them gone in a volume now. Everybody say volume? So you need to know the volume of the disk first. So let's find the volume of one disk. And then we're going to take this and see how much could fit in it. All right? So we want to start off with the volume of one disk first, okay? So the volume of one disk is normal, the cross section, or I could say area of, let me write that. So it's the area of the cross section times the thickness that we have right now. The area of the cross section was given already. We found it. It's 1,350. The thickness is 2. So we're looking at about 2,700 millimeter to the third power now. We're going in a volume now. Everybody talk to me now. Talk to me now how we feel about this. We're good? Are we good? We're good? Now, they gave you a conversion here already. You know? Look, a millimeter we're working at all along, but they gave us something in centimeter cube, but they gave us the conversion for it right now. For every 1 cm cube is 1,000 mm cube. So now you need to convert. I'm thinking you can't work with 2 different units, because we were working with mm and they gave us something with cm. Everybody see that? All right. So we need to convert to one or the other. All right. So you can do anything you want to do. You can convert. All right. Let us just convert this to cm right now. Cube. Yes.
What can you remind me of the formula for volume? Like
volume is area of, in reality, volume is area of cross section times height or length or thickness, depending on the context.
Okay.
Remember now, what is volume in its sense, scientifically speaking, is the space that something is occupying. So that is why if you find the area of the cross-section and how far it goes, you're actually showing the space that it is going to, for example, you are occupying some space. Whoever in your house, wherever they are occupying that space. We call that volume, okay? So in context for regular shape, area of cross-section times height or length or thickness in this case. Now, let me convert. I feel like I want to convert. We have to convert. We can convert the mm. It's up to us. We can convert the millimeter cube to cm cube. They told us it's 1,000. So that means we're going to take, therefore, where do I write this? All right, I could put it here. So therefore, we're going to take 2,700 and we're going to divide it by 1,000. And it's going to change to this. Let me stop there. So now we convert the volume of the disk from millimeter cube to centimeter cube so that we could put it into this. All we're going to do is divide it, because we want to know how many. Watch this. We need to know the number of disks that we can get from 1,000. So it's simply going to be 1,000 divided by the 2.7. And then whatever we get is the answer. So let's go. 1,000 divided by 2.7. All right. Now, watch this. We are getting some 370.37. All right, we can say 0.4 disk. But watch this. You can't get 0.4 disk. A CD we are talking about it. So guess what? It's approximately 370 disks. Talk to me now, man. We agree? Context to your question. We can't get 0.4 disk. That's part of one disk. So we can really make 370 out of it. Can't make no more. A little piece leftover material can't make a full disk. Talk to me, everybody. Are we good?
Yes, sir.
Are we good? We going good? Going good? All right. Right. Anybody want to ask anything?
Sir, I get the 1350.
Anybody want the 1350 was from the beginning, you know, when we found the cross section. It represents this. It represents that flat part for the disk. When we found the area of the circle and pluck out the square from the middle, we get that flat surface. We got that from working out this part when they asked us. You remember, man? Right, or so?
Oh.
All right.
All right.
Relax, man. Relax. No, let's keep pushing. Come on, we have to push to the end. It says here, a globe is a scaled spherical representation of the Earth. The actual length of the equator is 40,000 km, represented on the globe by 160. All right, centimeters. What length of string would represent an actual distance of 500? Come on, man. Come on, everybody, you ready? Think about it. All right. So we are looking at this fact that we are saying that, look, the actual length of the Earth, of the equator, is 40,000, right? And it's represented by this, you know. And then I look at this, 160 centimeter is equivalent or is used to represent 40,000 K. Yeah, man. So it depends on how you want to look at it. All right. Now, 1 cm is 40,000 K. 1 cm is to take 40,000 K and divide it by 160. This, I'm just doing ratio for you. Like, there's a relate. So you're going to get 250. Look now. At 250, look. Km now. 1 cm give 250 km. And look how much we want to find. 5. You see the answer yet? Remember, you know, me just break it down, show you right now, you know, and you could have turned it the next way. Me just turn it this way. Me just say 1 cm is 250 kilometer, and we want to know how much cm with 500 be. So then, the number of cm, right?
Sir, 125.
All right. For every 1 centimeter, it's this. So if you have 1 centimeter, it's 250. And then another 250. How much centimeter this? Because a 500, you go to, you know, that's so. 2 centimeters. Not you? Everybody say that 2 centimeters, sir? Everybody say that?
Yes, sir.
Me just do it one the baby way, and when we do a pep and say, you know, yes or no, you would have said, all right. You would have said it, you would have said this. You could say, I'm just talking to you now. You could say this 500. If I put the 250 in it, the 250, every time the 250 goes in, it push out 1. Look, 1 centimeter. So if you divide the 250 into this, you see the 2 come out? That's the 2 centimeters. That's what we're saying. So whichever way you want to prove it to them, it don't matter. 2 centimeters. You understand? And I could have turned it the other way. But let's go. Let's go. All right. Let's go. So 2 centimeters. Now it says here the distance between what's this? Palmyra and Quintic is represented on the globe by this 25. Okay. Calculate the value of the PQ, the actual distance in km. All right. Remember now, say we just found out that 1. Look at this. If 1 centimeter, we just said, gives us 250 km. Then if I have 25 centimeter now, isn't it true then I'm just going to say 25 times 250? Because 1 is 250, and I'm going to have it 25 times. How does that sound? Make sense? Somebody confirm.
Yes, sir.
For me, no, man.
Yes,
Confirm,
sir.
no, man. Confirm, no, man. 25 times. Yeah?
Yeah, 6,250.
Yeah, that's it. 25 times. So embracing the person, embracing the 1 concept is so important. Embracing that 1, that ratio, we say it's 1 give this. So 25 means 25 times what 1 worth. The same ratio and proportion, all the way from October class that. All right. Can we push? Talk to me, man. Can we push?
Yes, sir.
All right. Push it. Number 7 coming up. The fun question now. So it says a sequence of a figure, all right, is made here by length, unit, blah, 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 and it goes. Now, they want you to draw the 4th one. Take a look at what you're seeing first. And I will say to you again, this is the question I'm marking. Okay, this question. Then throw me upon number 7. So we can tell you all of the ins and outs and what we want you to do every time. But these are easy ones, right? Look at the pattern first. Look at the pattern. And then notice that in the second figure, see the first figure here? In the third figure, see the second figure here. In other words, then, you need to draw back the third figure. And all you're going to attach is just every time what you're attaching is this piece. Just look. You're attaching this each time. So I'm going to draw back this third figure. All right? Draw back the third figure quickly. Let me try it quick. So me have, see with me here. And I'll draw it pretty right now, though. Why am I think ugly right now here? Okay, people? All right, that look like which one of them? We have that. 1, 2, 3, 1, 2, 3 with this. All right, so this is the all right, so that is the third one, right? And then all you're going to do now, you're going to add, just add 1 more to it. Take a look again. See the second one here, and this extend already. You add this out there, and then now see the third one here. We'll stop here, say add this out there.
So just I got 2 more to that and then you do.
Yeah, man, like this. Good?
But sir, as easy as this a question, you would be why then can't give us one simple thing for draw? I would expect me to draw this.
Remember, I look on this and drive back, and then you add this at the end. Just attach it to
Just
it.
go ugly.
It no matter, man. So as a marker for this question, we look for the shape. As long as them see you do this, you're good to go. So we look for, let me tell you what you look for right there. So we look for this shape that you're supposed to have. Because believe it or not, when we mark the question, yeah, some people do this. Let's tell you. So you now get the mark because it not the shape. I mean, literally put the box them like this. That's what I'm saying. And then you have people who really have the shape. It's ugly, but we see you do the elongated thing like this. So when you have the right shape, is 1 mark for that already. And if you have the right number of boxes, you get the next mark. And 2 marks for the question. You understand? I tell you. So that we look for. So it's not about whether or not you can draw. Them know enough people are not artists. But we are looking for, do you have the right shape that you're supposed to have? And then do you have the right number of boxes? And the moment you do that, trust me, you're good to go. All right? All right, are we there? Are we there? Are we there? Any question? Any more question? Everybody like up the video and share, man. Like up the video and share. Tomorrow I examine, man. At the nightcap, this nightcap. All right, make we roll again. Roll again. Now it says study the pattern. Study the pattern of the numbers in each row. All right, of the table below. Each row relates to one of the figures, blah blah blah. You study, right? All right. So let me read that. But anyways, we're ready for the pattern. Again, there's only 2 types of questions they send here. They send one with a common difference between consecutive terms, or they send one when you look at it, like the last one we did. It's not about common difference, but you're seeing a raw pattern being displayed and you just reproduce it. Most times they're not going to send that. Most times they send this where you have to do some work. So again, whenever you get the sequence question in the table, look out if you're seeing a common difference between consecutive terms. For example, look, if you subtract 3 from 5, you get 2. If you subtract 5 from the 7, you get 2. You're noticing that there's a common difference there. Look over this one. If you subtract 8 from the 12, you get 4. If you subtract the 12 from the 16, you get 4.
Would it would n for figure S be 2n plus 1?
Something like that. I not do it yet, you know. I don't do the question yet. Between me and I look for the answer. But yes, you look like that. Definitely. Definitely. But watch this now. We are suggesting that when you see that, feel good because it's going to be nice. But even if you don't see that yet, everybody can get the spot here. Because the numbers are still running in sequence. First term, second term, third term, fourth. So because these numbers are still running in sequence, you could add 2 to the 7 and get 9, even if you don't see what's going on. You also could have added 4 to the 16 and get 20. Even if you do not know what is happening, everybody can get the 9 and the 7. So they normally set it up to give you 2 marks there first. After that, now, this is going to separate the grade 3 and the grade 4. Are you able now to get this? Again, if your common difference is known like this, it's 2. Your nth number under that row, like the S column right now, is going to start with 2n. And the one under P will start with 4n. All right? But may I hold on the 4n first. Now, let me go again. If there's a common difference in your column, start your nth term with that 2 times that. 2 times n. And then you're going to check. So this is when n is 1, this is when n is 2, this is when n is 3, and so on. You only need to check, basically 2 of them are 1, but we're going to check 2. So 2 times 1, because n is 1, so you say 2 times 1 is 2, and you ask yourself, what do I do to 2 to get 3? Do I subtract or do I add? If so, what number do I do? Anybody? 2 times 1 is 2, plus 1. So you're like, oh,
Plus
we need
1.
to add 1. So the moment you realize what you need to do, you put it in this right here. That means you're telling yourself that is 2n plus 1 work. And then you're going to try to verify this now. Just verify. 2 times 2 plus 1, 5. And you're like, yes, it worked. So we're going to know. For the final it worked, don't waste the time, right? It worked. So that means 2n plus 1 work for that. Let's find out for this one over here. The common difference is 4. So you're going to write 4 times n. You're going to check from the figure column to the p column. So you're going to say, okay, 4 times 1. 4 times 1 is 4. But how do I get 8? Anybody want to just tell me quickly?
You had
Plus
4.
Exactly. So you're going to say 4n plus 4. And then you're going to say, let me double check if this really works. 4 times 2, 8 plus 4 gives me 12. And you're like, bingo, it worked. So when it worked, now you're confident in that, you know you get the marks already. So you know that it's lock off already. Lock off. So what we're about to do now is we're going to find what's happening when S is 43. Observe your column, because the S column has 2n plus 1 as the master for that column. In other words,
they're going to be equal to 43.
Exactly. 2n plus 1 is equal to 43.
And they solve for n.
Sounding proper. So you're minus 1 from both sides. So now we're looking at 2n is equal to 42. And then we divide both sides by 2. N is equal to 21 right here. Now, since you know that n is 21, you are now able to move from n all the way to the blank. Hello? Because we know what n is. We already said it's 4n plus 4.
It's 21.
4 times 21 plus 4. And the answer is, waiting on somebody to tell me. Anybody got it yet?
88, sir.
Yes, very good. 88 sounds good. And that would have been the completion of this type of stuff. And whenever it looks like this, it is always this simple, I swear. If it is not this, the pattern will be so straightforward, you'll be able to just look and go. All right?
Sorry, I have some real odd.
No, sir, we never come on none yet. You can send it to me when the class.
Sir, I always mess up on this question.
I hope you don't mess up on it anymore, because it can't be more simpler than this. Trust me. You can go back, go watch as many videos I put on this topic. It's the same teaching, it's the same thing, and these would be past paper. So I don't like say we have make up this at this count. All right.
Sir, so the 4 times 21, plus it's same 4 coming down.
The 4 times 21. Talk to me. Tell me what you want to ask me.
The 4 that you put at there and get the 88.
What about it?
It's the same 4 that coming down.
No. No, it's not. So let me explain to you. So you probably, were you right here or did you go somewhere? Come. All right. Here is the deal.
What the 4 times 21 plus 4?
Yeah, man. So I gotta talk to you, because that's why I asked if you were here, because we did explain what we were doing. So I'm gonna do if you go and come back. But what I'm saying is, you want to find this spot, right? It's missing. It's blank. It is under the P column. Can you see this?
Yes,
see
sir.
this? P column is ruled by this. This is money on the boss for the P column. Read him. Can you read him for me quickly? Read the boss for the P column.
4n plus 4.
Yeah, you just said that. You just said the plus 4. And that's where it come from. Right, that's all.
Okay.
And that's where it come from. In other words, then, what is n in this column that you in this row? What is n in this row?
21.
21. So if you want to find the missing number under P when n is 21, we are saying it's 4 times n, but n is 21 right now. That is 80, that's 84, plus 4 more. This is a formula you work with, man.
Oh.
And you get 88. And the formula you substitute, All right, let me say it for the class. This formula here, it gives everything here. All right? This formula here give everything here. You know, understand what I try to say to you? The 2n plus 1 control everything for S. And the 4n plus 4 control everything for P. Trust me, it is that simple. Don't overthink it. Don't overdo it. It's not. All right. Let me see if we can jump to our next question now. Come on, man. We're ready, you know. All right. It says, determine the relationship between the number of squares S and the perimeter of the figure. Okay. Them say there's a relationship. Let me tell you what they must say. There's a relationship between S and P. And they must say, can you tell me? And me, I'm going to say to say.
If you multiply the first one, I guess.
All right, watch this now. You ready? Boy, you be very simple. I'm just showing you something. Whenever you learn something, you use it. What is the common difference here? 2, right? Everybody agrees that the common difference is 2. They're asking you to give a relationship between this and this. Don't change what you learn. 2s. Right? So it's 2s. So you ask yourself, watch this now. 2s is the common. 2s. And then you're going to check to connect to P. 2s. These are S now. And I end them now. Them are S. Everybody in the see S right? So go on, man. Everybody see S as a S them now. These are S. These are S. S. These are S. These are S. S. So we're saying, I'm just saying to you, just think about it. Right? And stop me show you in many ways to do it. I can show you the easiest way. The common difference is still 2. So it is 2s. So you ask yourself, 2 times 3 is 6. How do you reach 8? Somebody talk to me. Come on, man.
+2.
What you mean, man? Then they same pattern, man. Whatever I'm teaching you, I'm telling you, allow me again. See that? 2s plus 2. No more, you start check it all over the place now. Check, we're going to check now. Check, we're going to check. Hold on, I could clear up this. Because I said the same pattern. Not overthink them thing here. 2 times 5 is what? 10 plus 2, 12. 2 times 7 is what? 14 plus 2, 16. Come on, man. Everybody, even if you work upon this, you get it to you. You think I joke, Maron? If you work upon this, it give you this right now. Same thing. In other words, whatever you learn, it work. I tell you. So you know, but I overthink it. You just see the pattern again. Same 2, but that S you're going to use because that S here so. I know N. I know N in a S. But anyways, 2s plus 2 is the relationship. And you can see that. So if you double your S and add 1 more to it, you get P. Double your S, add 1 more to it, you get P. Let me repeat. Double your S and add 2 more to it. I don't know where I got 1 from. All right? All right, we're good to go. We're good to go. So we find out what 2s plus 2. You done, you know? 2 marks, man. Oh, God. 3 more questions to go. I hope we can hold out. We can hold out?
Yes, sir.
3 more questions to go. Let's go. All right, let's go. All right, so this one, you probably see it some time ago, but we're going to kick it. So the diagram on page 25 shows 6 points of the function. Y is equal to 3x plus 1 over x. The coordinates of 6 of the points are given in the table. All right, complete the table by filling in the missing. All right, so, all right, we know this already. We're going to plug 0.5 in a them function, and whatever we get, come here. So what is the function? I'm going to work out the 0.5. It says y is equal to 3x plus 1 over x. Now x is 0.5, right? So y is equal to 3 times 0.5 plus 1 divided by 0.5. Now I rush it. So I'm going to write out the answer one more time. When you multiply 3 times 0.5, you know, a 1.5 you're going to get. And when you take 1 and divide it by 0.5, you know, a 2 you get. So when this come together, you get 3.5. Everybody good? So we have 3.5 right here. This is 3.5. Now we are going to substitute 2 in the thing. Y is equal to 3x plus 1 over x. Remember now, x is 2. So we're substituting. Let me put it right there, so just in case somebody jump in and realize. Let me just put it there. So x is 2 right now. So y is equal to 3 times 2 plus 1 over 2. This is equal to 6 plus a half. This is 6.5. So we can call it 6.5 since we're in the decimal world. Talk to me now. Everybody, we good?
Yes, sir.
All right. All right. That good enough. 2 marks we're going with, man. We're going with them free 2 marks. Freebie. All right. Now, we'll see what I go on. Everybody stop and like up the video. Please like and share the video. All right. So we are at right here. It says on the diagram on page 25, the coordinates of this is shown, blah, blah. So we want to plot this. So we're going to plot this on the curve. We're going to plot ours. I think they plot everything for us already. We're going to plot our 2 points. We're going to plot 2 points. I'm minimizing this so that you could see it. So we're going to plot 2 points. All right, we're going to plot 0.5 with 3.5. 0.5. So for those 0.5 with 3.5. Remember, I know we want to think, because if this is 1, you're going to go to the middle of this. The middle of this is right here, because it's 0.5. This is where 0.5 is. And you're going to go up with 0.5 to 3.5. 3.5 is on this line. I'm listening to you speak.
Sir, so it's a common sense question, because I was looking for the scale to see, where 0.5 should be, but I realized I'm not using a scale, so I'm saying it is a common sense.
I'm using a scale. I am using a scale. The scale is there because they did the axis for you already, so it was scaled up for you. But I think I know what you're saying. You're saying that 0.5 is not on it. You are to find your 0.5, which is a lot of times they're going to do that to you. But it is scaled up. It is 1, 2, 3, 4, 5 centimeters to 1 unit on the x-axis, and 2 centimeters to 1 unit on the y-axis. That's the scale. So you are going to find your thing as you go. But I know what you're saying. And you're good, because you would have found this, right? Yeah, man, it's scale up for you already, but yeah. All right. Next point that we're plotting is 2 with 6.5. 2 with 6.5. 2 is this line here. And you're going up to 6.5 is right here. Right there. So we have 1 point here and 1 there. And we're going to draw our thing. Draw it. I'm going to use, give me a little bigger, let me get a slightly bigger red. Yeah, maybe. All right, this is not bad. It is not a quadratic, everybody. So don't try to get a quadratic curve out of this. This is not a quadratic. I'm going to use my freehand.
Sir, a freehand? Oh, yeah.
Yes, it has to be freehand. It's a curve.
It's a curve.
It's a curve. You only use ruler when it's not a curve. Moment it's a curve, like a quadratic, whatever, you just draw it like me. No, this not draw too bad for you. You just roll it. Roll your thing, man. Go on with the thing, man. Like that. Are you that? So they're looking for something like this. That's what they're looking for. It's not a quadratic curve. All right? So at number 8, they have its algebra function and graph. Nobody said it's going to be a quadratic curve. Any graph could come there. That is why speed, velocity come there, and so on and so on. You understand? All right. So this is the graph that you're looking for, definitely. Now, I believe that if they're going to ask me a question, I'm going to have to go to the other screen if we want it to look nice. So I'm going to just bring this to the other screen from now. Give me a second. Let me just bring this to the sketch graph screen. We can get a thing proper. All right. Blow this back up. All right. All right, let's see. I think the question was on top of it. The next question, all right. The next question, so you don't get 2 marks to do this. The next question said, by join appropriate straight lines. All right, find an approximate. See that? Find approximate solutions of where this function equals 6. This is the same curve. See that it. 3x plus 1 over x equals 6. So we're going to put this on our graph, right? We're going to put this on our screen here. Allow me to blow this up. I want it big and pretty. Hold on. Let's see how far. Give me a minute. 150. All right, let me take one. Let me take this. Can dry it up a little. All right, like this. So what we're doing is we want to find the solutions when it's equal to 6. When the function equal to 6. So we're looking at 6 on our y-axis. And you're going to, this line, run through 6 right here. See that? Through 6 right here. Boom. Right? And then wherever it touches the curve. So I'm going to just blow it up now. And we're going to try this on interpretation. See there? So wherever it touches the curve now, you're going to mark that. So it touches the curve right here. So from up on the line here. And this touch the curve. Why my curve big and ugly? So I'm going to just touch it. So don't crucify me. All right. So me I work with this line right here. All right. Because this me I work with. Okay. So you touch the curve right there. So when you're doing a question like this, they have various answers. They have a range of answers that they expect from people because they know everybody will not draw their curve the same. So they have a range of answers for this. Okay. But it can't be too far. So where it touches it, mine, I could bring this down. I'm bringing this down and I'm going to read off what this is down there. This other one here, boy, I'm bringing this down here. And I'm going to have to read off that, whatever that is there that I'm getting. Okay? Now, you could see, so we drew the line where the function was equal to 6. And then now we bring it down to the x-axis to get the solution. What are the solutions there? So I'm going to push this up because I'm now going to focus on those 2 places. I'm going to magnify this for clarity so we can talk. So let's discuss this thing now. Now, it is scaled. Now you're going to have to understand and find out. Look, this is 0, this is 1. If you take a look, you're realizing that this is 0.2, 0.4, 0.6, 0.8, then 1, and so on. So in order for me to get what I want, I'm going to have to focus on a certain gap. I'm going to have to focus on this gap right here. This gap is 0.2, or what you will call 0.2. I'm going to divide it up into 5 equal pieces because I am noticing that we have 5. Look, if I blew this up for us right there, you notice that it is divided into 5 equal pieces. It's like it's divided up into 5 pieces. Take a look. It's divided up into 5 pieces. So 0.2 was divided up into 5 pieces. So I need to know what one of those lines represent. And the moment I know what one line represents, my answers will be coming at me like a bullet out of a gun. All right? So let us now divide that 0.2 into 5 equal pieces. So 0.2 divided into 5 will give you one of those lines. One line, I'm just writing this for us, is equal to 0.04. 1. Now, my first answer, come on, everybody. My first answer is right here. My first answer is right here. Right here. And it is 1, 2, 3, 4 of these lines. So in other words, then my first answer, x is equal to 0.4 times 4. 0.04 times 4. Times 4.
0.16.
This is one of my answer. Remember now, it has to do with what I drew. All right, let me tell you what they do here. When they're marking you here, they are marking you for how you interpret your answer. So whenever we're marking here, they say we're doing a follow through. So when you're done draw your graph, even if your graph wrong, and you're interpreting the 6, when you come down with it, we are going to give you the mark if you read the scale. At this moment, we are testing you for scale reading. Can you read the scale? Your scale. So this is what I got. I got 0.16. Now I'm going to come over here. So this is 1.2, 1.4, 1.6. This is 1.8 already, right? So right here is 1.8 already. And then I have two of these lines, 1, 2. So on my 1.8, I'm going to have watch this, 0.04 plus another 0.04 because it's two of them. Look for yourself. And this has to do with me. This is what I got. So I'm going to put it on my calculator because this is a tricky one. Plus 0.04 plus 0.04. My answer is 1 point. So my second answer here, x is 1.88. That's my second answer. So my two solutions are as follows. X is 0.16. X is 1.88. So if somebody asks you again, where do we get this 0.04? We found out that one of these lines is 0.4. And mine is on the second one here, away from 1.8. So it's 1.8 plus 0.04 plus 0.04. That's the simplest way I can put it. And then we touch it and we gone. Talk to me, no man. Somebody talk to me again, no man. Somebody says something. Are we good?
Yes, sir.
All right. All right. So we go on. We are touch it again. All right. I think the question I go finish. Normally, see, there's so much marks I'm giving for that. 3 marks. All right. All right. So last after number 8 now. So this number 8. All right. Number 8 now is a speed time graph. Last night we touched this in class. I feel like we did the exact question there too. Yeah. All right. So it's
It was the exact question.
Yeah, man, we do it. Not true. He
Yes,
said the speed time graph below shows information on the first 60 seconds of a car's journey. We're looking at it. So the first question says calculate the acceleration in meters per second square of the car's journey. Stage B. Acceleration is change in speed or velocity with time. So stage 2 of your journey would have started here and ended here. Now you want to pick up those speed. So you want to come across here to know what the speed was there. You need to because it's a change in the speed over the change in the time you're dealing with. You come across here, you want to know there. So you're talking about initial and final. But if you don't want to get to physics,
change in speed would be 25 meters per second.
Exactly. So let us put some scale into this. This would have been 5, this would have been 15. So we know that this is 15 right here and 40. So the change would have been to say 40 minus the 15, which is 25 right here. So this is a 25 gap from 15 to 40. And then you're focusing on the time. It started at 40 seconds and then ended at 60. So this piece is 20 here. Those are the numbers. In other words, is the gradient you're working out. The acceleration is the gradient of the slope. Come on, man. Vertical over horizontal, same thing, you know. A slope, you know. So when you're doing a speed versus time or a velocity versus time, your acceleration is actually the slope. So if you can't remember a slope of the line where I find, why you think me I say rise over run? In other words, I can work this out without calculating. Honestly, we just don't like to do too much sometimes. Because if I create a right triangle right here, we can count it. 5, 10, 15, like 20, 25 over. You understand? 25 over, and you count it up, 20. 25 over 20. But we are going to work it out. This is a show now. Make we work it out, man. So we are saying, we can write it down. Acceleration is change in, I'm going to write speed here because it's a speed time graph. Velocity, same thing, over change in time. This is going to be 40 minus 15 over 60 minus 40. Basically, 25 over 20. Whatever you get is the answer.
1.25.
So this is 1.25. And the appropriate unit is meters per second squared. If I'm not using the slash, you will see me using a negative. But it don't mean nothing. It's just that I'm not using the slash. All right? Let's go again. Let's go again. Let's go again. Let's go again. Calculate the average speed of the car during the journey of stage B.
This is total distance over total time, but we have to work out the distance.
Very good.
The area
Excellent.
of the shape.
Very good. That's what we're doing. Distance, yes. So average speed, as I said, total distance over total time. But this is a speed time graph. You're going to have to find the distance, which is area under the curve. So you want to mark off the curve, and it's stage B they're talking. Can you find the area of this shape I'm shading for you right now? See it there? They are shaded. Oh, what is man? What is man? All right. That we want to find the area of this shape right here. This is a trapezium. All right. So the area of it will give you the distance traveled. Remember now, let's talk about the side length. Let me use some bigger marker here. This side length here is 15 coming from here. This side length here is coming from here. It's 40. Okay. And this here is 20. 40 to 60, that's 20. I'm just highlighting the shape for you. We are finding the area of this right there. All right. Now let's scroll up. So I'll go back there. Let me write the formula for us. We were asked to find average speed. Average speed by definition is total distance divided by total time. Now, at this moment, we know the total time already. The distance would have to be the area of that shape. So I'm going to say area of the trapezium, which is a half. Let's go back to it. A half, 15 plus 40. So it's a half the sum of the parallel side times the height. The height is 20. In terms of, look at the height has to do with where the right angle is. This is where it is. Okay? 20. Parallel sides are 15 and 40. So it's going to be 15 plus 40 times 20. Work out that, somebody. This is just the distance we're getting, you know. That's distance we're working on. So 15 plus 40 is 55, right? Divide that by 2 times it by 20. We're getting about 550 meters. That's the distance.
Yes, sir.
So now, in terms of the average speed now that we said we're going to work out, it's going to be the 550, which is the distance over the time, which is 20. Because it happened over 20. So if you want to go back, we're working out the average speed over stage B, they said. So it's right here. So 40 to 60, that's a 20-second gap. That's why we have 20 here. So somebody divide that by 20 and tell me what we get. 27.5
27.5
meters per second. Are we good?
Yes, sir.
Everybody, we're good right there? All right. Now, at time t equals 60 seconds, the car starts to slow down with a uniform deceleration of 2.5 meters per second squared. how long before the car comes to rest. Deceleration is negative acceleration. So I'm going to write the formula with acceleration. Acceleration is your speed divided by the time. We have this, and we have the speed at the time when it happen at 60 seconds. So go back to the question. What is the speed when we were at 60 seconds? When we were at 60 seconds right here,
Speed was 40.
the speed was 40. Right here, 40. So that means we're saying that we have a speed of 40 that will be changing gradually until it becomes 0. So acceleration is 2.5. Substituting here, 40 over the time it's going to take. So then, if you transpose, time will equal to 40 divided by 2.5. 40 divided by 2.5. It's going to happen over 16 seconds. So in 16 seconds, it's going to stop. Question finish. Anybody again? Anybody again? Number 9. Why? We are trying to finish. You think we can go to the end? All right. If you're not book, you tell me, you know. If you're not tired, because me can't, me not making it tired out. You know.
How much question leave, sir?
9 and 10.
Okay.
We at 9.
Finish software.
Huh? All right.
Finish it.
Continue, sir.
All right. So it says the diagram below, not drawn to scale, shows the relative position of 3 reservoirs, B, F, and G, all on the level. All right. No problem. Diagram. So we see this. Everything is on. All right. Everything is on. Determining the bearing of B from F. Key. From this part, this is where you start. So the bearing of B from F, this is where you start. From F. From F. So you drop your thing here. You drop your thing here. And then you want to find all of this. Right? You want to find all of that bearing of B, but from F. All right. There are a couple of things where you probably can do to look at it. All right. Let's see if we can look at it. You will know here that, hold on. Give me a second. Let's see if we can put that little, all right. All right, so this is your knot line here. And if you notice this Z angle here, my bad, this is 42 here. And 42 will, if this is 42 right here, that means this piece is 61. This is 61 right here. All right, everybody subtract that and see if I get 61. So in other words, 103 minus the 42. I think it's 61. Let me just do it. Everybody get the 61?
Yes,
all right?
sir.
Yes.
All right, good.
Yes, sir.
Now, let me say this to you. Would you agree? Would you agree, right? That there are many ways you can look at this, but I'm going to, let me just do this for you. I'm going to use a bigger pen to show you so. See a big pen here. All right, let me go bigger. This is probably too big. Hold on. Let's steal it down right here. All right, so this is south, right? You agree that from north to south is 160? Everybody agree? The line I'm going to draw down 160, agree?
Yes, sir.
So that means the bearing from F, remember you go to the north of F and you want this, right? You agree? You want all of this, right? You want all of that. But would you agree that 180 stop on this line right here, like 180 stop right here, so plus 42 go there? Would you agree that this is 180, north to south, plus 42? You get the answer? Tell me if you agree. If not, I can re-explain.
Sir, me kind of lost right this.
Let me re-explain. Let me re-explain. Not wrong, man. Let me re-explain it for you. That's why I say, me stop. Watch again. They want the bearing of B, but from F. So they want this. They want all of this. They want all of that. Right now. But you have a lot of clues already. I'm saying the Z angle, put 42 here. You know this is north and this is south. From north to south is already 180 by itself, natural. You agree with that?
Yes,
north to south. So isn't it true? Isn't it true that the bearing that we want is 180 plus the 42? Because 180 plus the 42, you know, remember say, yes, this is what you're doing, you know, you want all of this. This is 180, then the 42, and you get it. Tell me if you see what me answer, right? So that's the bearing that you want. So it's not every time you're going to do a bag of workout. Sometimes the question is simple. So this 180 from north to south plus the 42 now give you the bearing of B, but from F. Tell me what you get. 200 and something, 222. Now, another way you could have done it, which is easier. You ready for it? The easiest way I think you could have done it is this. Watch again. I'm going to show you our next way now. That's a one way. The easiest way you could have done this is this. Take a look. Now, you still have to highlight this. And you still have to highlight the fact that you want all of this. Would you agree that if you subtract the blue part from a 360, you are left with what you want? Talk to me. Because the bearing of B from F is the red. So the whole thing is a circle. So right here is a circle. 360. If I take off the blue part, I'm left with the bearing that I need. Remember, co-interior, when you have two lines parallel like this angle plus this angle add to give 180. No. If I take out 42 out of the 180, look what you're going to get. Somebody work out that. 180 minus 42, this is 138. Now, if I take out that blue part here, this is 138, everybody. This is 138. If I subtract the blue part from the circle, I'm left with the part that I want. So you could have said 360 minus 138. You're supposed to get the same answer. Let me double check it. 360 minus 138, same answer. I'm just saying there are various ways to do it.
Yeah, I think it's weird kind of better.
As I say, there's no better, there's no worse. It's what you are aware of. All right? But you'll get the same answer. So whichever one you're comfortable with, you write it. I'm just saying. I'm just giving knowledge as we go. All right, make we move now. Make we move. I move now. So I'm going to clean up the diagram, people. So we get to bearing is 222. May I clean up this for now? All right? All right, let's go. It says here, calculate the distance BG, giving your answer 1 decimal place. So BG. Now they want BG. I'm going to work it up in this section. All right, so everybody can see. So may I clear up. We want to find BG. Now you're noticing then that BG is going to be the cosine rule because, yes, because you have an angle between two sides.
Yes, sir. So
and you're finding the side across. All right, good. So here it is that we could say, where do I write it? I'm going to write it at the wrong place, people. I'm going to put it right here. So ignore me for now. I need the space right here. So I write this. So we're doing BG square is equal to 32 square plus 55 square minus 2 times 32 times 55 times the cos of that angle. Work with me. When you square 32, what you get? 1024. When you square 55, what you get? 3025. And remember the deal. You put all of this part on the calculator at once. All right, put all of that green part on the calculator at once. So it's minus 2 times 32 times 55 times the cosine of 103. And it's going to give you a positive number, 791.8. Work out this now. 1024 plus 3025 plus 971.8. So you have 4840.8. BG is to take the square root of this. Huh? BG is to take the square root of that. So what is the square root of this? So we're talking about the square root of that. And I'm getting some 69.575. But to one decimal place, it's approximately 69.6 kilometer, because they definitely says, give us this to a certain decimal place. So most times when you do bearings, you're going to always go back to this same thing. Cosine rule, sine rule. So we have that. So the answer is 69.6. Can we go to the next one quickly? Quick and fast. 69.6. So this is the question we solve, guys. It's a 2-mark question. So this 1 mark here is not for that. All right. All right. So we found BG. Next one. Calculate to the nearest degree. Everybody pay attention. Nearest degree. We're told to calculate to the nearest degree. And the bearing of G from B. Very importantly. G from B. G from B. B is where you're starting. And we're going to G. Let me go back. B. Starting at B, and we're going to G. Oh, B, G, this. I'm going to do it right here. Here is the deal. We have 42 out of that bearing already. That means we need to only find this angle in the triangle, which has an opposite side. And then the 103 has an opposite side. So we can set up a proportional equation and solve to find the angle in the corner at B. And then add it. Yes, very good, sine rule. So you start off with 69.6 over the sine of 103 is equal to 55 over the sine of the angle that we want. What you want must be a part of the game. Then you can cross multiply. So you can cross multiply here. So this is going to be 69.6 times the sine of the angle that we want. It's going to equal to, cross here again, 55 times the sine of 103. Finally, you can divide both sides by 69.6. And then the sine of the angle will give a value. Now, work it out slowly. All right, work out your thing. Make sure you understand your calculator too. Divide by 69.6. You should get this value. So I'm going to write the value that I'm expecting, I'm anticipating. All right. So I am anticipating you to have some 0.7699 R. I think this round off. So let this, there's a 9 after that, right? Or a 7. So I'm going to write, let me write it. There's a 7 after that. So let me just deal with it. So 0.700, something like this we'll get because of how the numbers are coming. So you're going to do a sine inverse of 0.700. 0.77. Because the 0 doesn't matter at the end. And it's going to give you the angle that you need. Sine inverse 0.77. Let us sine inverse 0.77. And it's giving us some 50 point something. So we're getting 50.35 degrees. But they did say to the nearest degree. But let's work out this to the end. This is 50, say 0.4. Right? So what we're going to do now is to get the bearing, because now we're going to add both. You're going to add that 42 that was there long ago to the 50.4. Let's go. So I'm going to go to the right section. Or is it that you need, you know what, let me answer it here for you. You're going to add that 42 plus the 50.4, and you're going to get some 92.4. But remember, the question says to the nearest degree. So the bearing that we're looking for is 92 degrees, because they did say to the nearest degree. Then you could put a 0 in front of that, because bearings normally use 3 digits, and if, you know, it says 0, 9, 3 is good to go. So this is the bearing. This is the bearing of G from B. So this is what you would have put at that section. All right, I know everybody I get tired, so I'm gonna just keep rolling. Keep rolling, keep rolling. All right. Everybody ready? Ready
Yes.
again?
Yes, sir.
All right. All right, let's go and keep it going. All right, so I think that was probably the final question though for 3 marks. We in the circle section now. Come on, let's go. Ready? We in the circle section, I believe. Yeah. All right, let's go. So the question says, it says here, the diagram below, not drawn to scale, shows a circle with the center O. That is important, center O. The points A, B, C, and M are on the circumference of the circle. The straight line CN is a tangent to the circle at the point C, and it's perpendicular to BN. All right, we're seeing everything there. Why not? You feel like more and take this to the next screen. So normally I'm up on the next screen. Let me have more space over this. All right, so I'm gonna read from here. All right. And then I might do the questions on this screen, but I'm reading from the other screen, right? Let's blow this up a little bit to get some more. So it don't look too slim. All right, this is it right here. All right, push this right there. All right, make we go now. Question time. Question time. First question, determine, give a singular. Be careful, don't do too much, don't overdo it. They said give a reason, so it's 1 for your answer. ABC. All right, so we're looking at ABC. All right, so number 1 is ABC. All right, so we want number 1, it's ABC with this angle. That means look where ABC is, A to B to C, right here. That's what they want, ABC. Bear in mind that they gave us this, so we're going to highlight what we got. We got this diameter, and I'm seeing angle in a semicircle down here, even though they didn't say, but this angle here is 90. So because I know that this is 90, I'm now able to find this third angle in the triangle, because if I take 180 minus the 90 plus the 58 altogether, so it's 180 minus 148, it's about 32 degrees, right? So that's about 32 degrees. So I'm going to drop it. Normally I put on my labels, it helped me. So what's the reason that we could put here?
Angles in triangle.
Huh?
Angles in triangle.
Yes, you can write that. Yeah, they said write a reason. That's all right, because you use it in the end. Or you could have said angle in the semicircle as well, because you needed this as well to help you to go forward. Any one of them you wrote would be good. All right? Anyone. So let me just write 1. I'm just going to write that angle in a semicircle equal 90 degrees. So I utilize that first. All right. You don't have to write that. You could have written the total angle in the triangle as well. All right, let's go to the next question. Next question. So we get 2 marks. One is for 90 and one is for the reason. We're doing CMB. Second one. CMB right here. Mark your angle. CMB. CMB. Where's M? Right here.
You're gonna take the it's supposed to add up to 180, so you're gonna.
Very good. Very good. It sounds as if you saw the cyclic quad.
Sir.
Cyclic quad.
Opposite angles in our cyclic quadrilateral at
Yes.
180.
Yeah, man, on the on top form, and I will kill you exam, and I'm telling you.
So that's a 122?
Yeah, man. So opposite angle in a cyclic quad. So first, when you see this, you just start think. But the fact that you see this cyclic quad, man, then no, opposite angle add to 180. Not true. Opposite angle add to 180. So yes. So this is going to be 180 minus 58. And you're going to get 122 degrees. And you can just say opposite angle in a cyclic quad. So opposite angles in a cyclic, I'm just going to say quad, all right, adds to 180 degrees. Or you could say are supplementary, up to you. All right, so I'm going to clean up my diagram here, and then I'm going to put on what we just got. We just found out that this is 122, we're good. Good to go. Now go on, trust me. Now go on. All right, let's go to the next question. Next question, say NCM. NCM. Question 3. We want N, C, and then M. NCM. Now, again, when you look, at this is a little triangle by itself, but here is a straight line. So what I'm going to do is to come on the inside of the triangle right here. I'm going to come in there, right here. I'm going to come on this side now. And then I use this and the 90 degrees to find this missing angle over there. Now, stress it. So what we're going to do is take 180 minus 122, and we get what? About 58. So we get 58 for this angle in the triangle right here. So now the angle that we want is to say 180 again, minus the sum of 90 plus 58. And what we want to get for that? What we get? The 32 still, right?
Yes, sir.
32. So that angle there is 32 degrees. Now you can use anything to give it. I'm just going to say straight angle measures. I'm just going to just kick it. I'm just using the first thing I got. Straight angle measures 180 degrees. I'm suggesting that when I start off right there, I needed that clue to keep it rolling. You could have said total angle in the triangle give 180 as well, because you utilize that in the end. You get it? Can we go? Circle not too bad, man. Circle not too bad. Trust me. Last, you done. You see what I talk about? Done, man. Come on, guys. We only have like 20 minutes and we wrap it up now. Come on, let's go. It says here. Thank you very much for this question. I had it in mind to mention this to you, and it slipped me when we were doing transformation. What if they give you something like this? So I buck up why the question there, because I never looked through it. But anyways, let's get to it. Let's get into it. This question now says here, the transformation T is defined by the matrix T equal to this. So they gave you that. Let me tell you what's going on. Whenever you reach number 10, I said it to you that they can give you raw matrices, or they can give you transformational matrices. They can give you transformational geometry, which is to give you this, because they know that transformation comes in matrix. You notice when you have the transformation, you have to put the things in a matrix. So they can give it from matrix and then give you a vector question after. That's what they're going to do. All right. So here is the deal now. We're saying we have the transformation, but read now. It says the point A, which is negative 2, 3, is mapped onto A prime, right? Which is this, under that translation. Find the coordinates of that. All right. In other words, we're going to take this matrix and multiply it by the points. Remember that the matrix always go to the left. So the matrix will be written first, right? So it's like, it's always set up like this. The matrix is always here, and the point comes after here. Matrix, point. Okay, that's the setup every time. Every time. So now we're going to put our T matrix here, which is 2, negative 1, 2, 0. The point will go next to it, but in a vector format. You can't put the point regular. Like this, you're going to have to set it out. Then you're going to do row by column. Let me highlight my rows. Row 1, row 2, column 1. So you're going to do your row by column, and then when you're done, the answer will pop out at you. For example, I'm going to write it 2 times negative 2 plus negative 1 times 3. Right? And that's at the top. Underneath, 2 times negative 2 plus 0 times 3. What do we have? Negative 4, negative 3, negative 4. This is actually negative 7, negative 4. In a response to the question, remember now, in terms of a coordinate, you're going to have to tell them that, hey, for the coordinate, you know, the coordinate is this, negative 7, negative 4, because this is how you write coordinate. Be careful. Don't leave it in the vector form and think so you're good. You're not good. All right? Put it in this form so that they know that you know your language. So A will be the one in the front, which is negative 7. B is the Y coordinate, which is negative 4. This is regular matrix multiplication, and that is why they could put it in matrix, but they're mingling it with transformation to see if you know to do your transformation and matrix. All right? All right. Are we there, everybody? 2 marks for that. Talk to me in the class. Are we there? Sister, I cut 1-1. We soon done, man. All right.
Sir.
No. Yes.
Yes, sir. I'm here. I'm still here.
The negative 7 and negative 4, where it come from?
What they told us to do. They told us to do what they told us to do. They said to us, map this point onto this using this. So we did it. Matrix multiplication. Multiply your matrix. May I tell you a straightforward.
Yes, sir. Me get
regular
it.
maths.
Me get it.
Regular maths. All right. So what I'm saying is, don't overthink these things. Just go.
Yeah.
It's regular. All right. So you multiply. Okay. Now wake up, man, because me have work a man and I'm still there. It says determine the transformation matrix. Watch this now. Ah, I like this. Watch this. Watch this. Watch this. So, ready? This was A prime, right? This was A. Everybody, talk to me now, man. So watch this now. A was mapped onto A prime. Look what them said. Determine the transformation and make it that maps A prime to A. If A map A to A prime, what will map A prime back to A? I want to see if somebody will get this. What type of matrix are you going to have to think about? Let me see anybody will think. If I use a identity. Huh? Not identity. Listen what me ask you. Listen what me ask you now. Me not tell you if I multiply these. I'm saying a matrix multiplied by A to give you A prime. How can I move from A prime to go back to the original? What concept in matrices you think you can use? It starts with I, but it's not identity.
Inverse.
Exactly. Does this look like a reverse to you? Like you move from image? Look, man, come on, man. This is object to image.
Okay.
And if you move from image to object. Ah, inverse of the matrix. Which matrix? The same matrix where you have up here. So you're going to find the inverse. So watch this. T is equal to 2, negative 1, 2, 0. You just realize that you need the inverse. We're going to find the inverse of t. How does that sound? The inverse of t is 1 over the determinant of t times the adjoint of t. Are we there? Yes, ma'am.
Yes,
So
sir.
so we're just going to you're going to do your thing now. Let us relax. Let's go for our determinant. Determinant of t is to go 2 times 0 minus times -1. Are we there?
Yes,
So what are we looking at? 0 plus 2 is 2. Huh? So the determinant is 2. I'm ready for the inverse now. Normally, if I'm find determinant, I'm done. So man in here just say the inverse of t is 1 over 2. Switch the main, change the sign on the other diagonal. Hello? Then I would want you to slide it in there. So 0 over 2, 1 over 2, negative 2 over 2, positive 2 over 2. I still want you to finalize it. 0, half, negative 1, 1. That's the matrix that go backwards. Talk to me now, people. We soon done in a man. Hold it now, man. Hold it now. Hold it now. We soon done. Hold it up. Hold it up, man. Come on, man.
Or when them ask for the inverse, we have it out, come thinking that just leave it to the
I said it to you before. I don't leave it. When I don't leave it like this. If I'm going to use it, I use it in this format. But if I'm going to give it to them, I give it to them properly done. How does that sound?
Okay.
Remember the difference. Remember the difference. I am saying if I'm going to use it and I don't want to work with fraction, I use it like this. But if I'm going to present it to them and go on about my business, now I'll give them the final product, man. Come on. Give them the final product. This is not about rushing. Right? Right? All right, let's go. Let's go. Let's go. Let's go. Let's go. Let's go. All right. It says another matrix P. This is what I'm glad to show you. Final touch them in, or they may like the extra. All right. It says another matrix P is defined by this. Right? Another matrix P is defined by that. The question says, find a single 2 by 2 matrix that represents a combined transformation of T followed by P. I never said this to you, but I'm going to say it tonight. T followed by P. What them say, sir? T followed by what? P. Watch this. Isn't it true I said matrix and then point? Remember I said that, right? Matrix and point. In other words, the point must always be to the right. The matrix that is going to affect you will be right beside you now. So if them say T followed by P, that means T are going there as a first affect whatever it is. And when it done, P are going to affect them now. Watch this now. T followed by P means that the T comes inside and the P the outside. The last one, the outside. So even though it look weird to you, you're going to set up this, right? Again, let me repeat. The last matrix is on the outside. And when we say outside, it's to the left. Because the point will be on the right if you're going to use it on it. So the matrix that you use first. So when they say T followed by P, T is the first one. So the first here, second, third, and it goes like that outward. Okay? Which means that you're going to have to put the P matrix to the left and the T matrix inside, because the T1 will be used first. Let's go for T. T is 2, -1, 2, -1, 2, 0. 2, -1, 2, 0. Look at the reverse now, man. T followed by P. This is first. This is second. Look how you write it up. Pay attention to this, right, Yasa? So what they're asking you is just to give them the matrix. And remember that matrix multiplication is not commutative. So you can't put anyone anywhere. So make sure make sure you put it in the right order. Right? So in this case, row by column. Come make me rush it through them. Row by column, people. Let me touch it. Row, row. Column, column, column. Let me take off the blue there. Take off this. Take off that. All right. Row, row, column, column. Let me work now. Let me get a black marker. Let me mark this. Row 1, row 2, column 1, column 2. Make we go now. Row 1, column 1. So it's going to be 0 times 2 plus 1 times 2. 0 times 2 plus 1 times 2. Row 1, column 2 next. 0 times -1 plus 1 times 0. Row 2, column 1. 1 times 2 plus -2 times 2. Row 2, column 2. 1 times -1 plus -2 times 0. All right, so we set up with thing, we relax. You can't make mistakes so easy as well. Everybody, make it work. This is 0 plus 2. This is 2. This is 0 plus 0. This is 0. This is 2 minus 4 minus 2. This is -1 minus 0, -1. Tell me if we're good right this. Good?
Yes, sir.
Yes, sir.
All right, all right, all right. So this is our matrix. 2, 0, -2, -1. That is the matrix that can represent the combined flow. Without doing them one by one, this one matrix combine them together. And if I use this on the point, it's going to happen the way it should. Nice and easy. Hence, oh, they want you to use it now. See that? Them say hence. You know what hence mean? You must use this. Like they didn't say hence or otherwise. Them say hence. You hence find the image of this under the combined. You see what I'm talking about? So you're going to take your combined thing. Take your combined thing. Work it by your point. See it there? Row by column again. Come on, man. Row by column. 2 times 1 plus 0 times 4. -2 times 1 plus -1 times 4. Two plus 0 is 2. And the -2, this is -6. But remember, this is not a coordinate, please. So remember, the coordinate of the image is going to be 2, -6. Everybody, that we are talking about. This is called matrix. A matrix them do, but them put in a transformation. This is the hardest way they could give you a matrix because they're combining 2 topics in 1. So you have to work out your matrix while. All right? We still a wallet, you know. We still a wallet. We still a wallet. We are wrapped up. We are done now. We are wind down. Everybody, if you don't subscribe to the channel, you can subscribe to the channel. We are wind down now. We are wind down. We are wind down. We are wind down. Come on. Let's jump into the fun part now. Vectors, the most feared topic. But make we see it go. All right. It says the diagram below, not drawn to scale. So don't use your eyesight and say this look bigger than this. It says shows a quadrilateral ABCD in which AB is equal to M. See there? DC is equal to 3M. See there? AD is N. They gave us all we need. Now they're going to quiz us on questions. Now, first question says, complete the statement below on the geometric properties of the following vectors. All right, let us get into it. Vector AB and DC are dash. I love to mark up things, you know. AB and BC. Anybody from my class can observe and tell me what is it? What? They are
parallel.
Yes, sir. I'm telling you, someone I will kill the exam tomorrow, you know, man. Oh, that sound like Nadine, so.
Yes, sir.
Yes, Miss Light. Ready for them, eh? Parallel.
Yes,
they are parallel because one is a factor of the other. You can't M 3 times M. Everybody see that, right? So we have that down. All right. Anybody remember the relationship when I always tell you, when you find out, for example, we are seeing here that 3 times the vector AB.
Oh, sir, when you can multiply one thing to get the other.
The length. All right. All right. So it is going to affect the length. Yes. So how do you say it now? Relax. Look at the size of the thing and don't make a mistake. It says, watch this. It says the magnitude or the length of AB is dash times, this is the key thing, the magnitude of BC. Think about it first. So because the scalar factor is 3, only 2 things can come to mind. Am I going to multiply by 3 or am I multiplying by 1/3? Because only these can work. Hilton always pick a fraction and somebody else always pick the whole number, but it no matter. What we're saying is, put it in the right context now. AB is a dash, or AB is dash times CD. CD is the longer one. CD is the longer one. So what are you saying? The length of AD is dash times what? CD. What do you put? 3 times or 1/3? Going once?
1/3.
Yeah. What you mean, Danica? Kill them off. A 1/3. Because the smaller one is 1/3 the big one. Think about it, you know. The smaller one is this. It is 1/3 the bigger one. It's 1/3 of the bigger one. So, but the reason why you had to put 1/3 is how they phrase it. You understand what I mean? All right. Yes. Yeah, man. Go on with them, man. Kill them and go on. Next question. Next question. Look like we are, we done. Almost done. Make a wrap it up. Because no one got me bed now. Let me teach from about 5 o'clock today. It says express BC in terms of M and, all right, BC. Where BC there? See BC there? So normally when them ask you, draw your arrow, you move from B to C. We are going around the world in 80 days like Jules Verne. Anybody read book? Round the world in 80 days. So we are going to go B to A to D, D to C. Mission accomplished. Everybody agree? Yeah?
Yes, sir.
Remember we say vector simple thing. I just walk, you walk, you know, man. You walk. In other words, then, we are going to say that BC is to move from
AB to
you're going to move from B to A plus A to D plus D to C. How does that look? Good?
Yes, sir.
All right. Now your arrows. Watch this arrow change. So you're going to go negative M first. Everybody agree? Negative
yes, sir.
M.
I want to change direction.
Oh my man. Not you're ready, man. You're ready, man. So negative M, but the N is going in the right direction. And the 3M is going in the right direction as well. So now let us finalize it now. Collecting your like terms, you're only going to have N plus 2M. Tell me if you don't agree with that.
Yes, sir.
Yes, sir.
You're getting harder than that, man. Now, 1 mark, you know, because they must say everybody's supposed to say that. Yeah, man.
Excuse me, sir.
Yes, go ahead.
So where did you get the 2 in the final part?
The M, can just M. So once you say M.
Yes, this negative M. Negative M mean negative 1 plus 3. So regular negative 1 plus 3 is positive 2. And the variable was M. Make sense?
Yes, sir. Thank you.
All right. I tie it up in the night time. Yeah, man. All right. They're on the last lap now. Where we there now? Where we there? All right, it done. Enter you see 12 marks, done. 36 mark in section 2 and 64 in section 1. All right, let's go. Double. All right, so it says L is the midpoint of CD. Find BL in terms of, all right, L is the midpoint of CD. L is the midpoint of CD. Do we have CD? Of course you have CD. Hold on, man. Can't let me clean up this, man. Hold on. Clean up this. Clean up back my diagram again. Them say L is the midpoint of CD. L. And then what them ask to find a BL? Is it BL them ask to find?
Yes.
I'm gonna go back and look if I really BL. A BL and I'm done, we're done then. If L is the midpoint, that means this is 3 over 2m. And yes, 3 over 2m. Not true? Talk to me now. Where L drop, it are going to split 3 into 1.5 and 1.5 now.
Yes, it drop right in the middle.
Then, you know, so the short way out, me I take, you know, so yes, me I take, me I go a short way, me I take a triangular walk. Me I go BC and then CL and done. How does that look?
Yes.
Yeah, man, that's the easiest way that. The next one little longer. So me I go now. DL is equal to moving from B to C. Can we just find that? And then I go add C to L and we're done. Now, BC, we have BC in the right form, right? We just BC. So I go move from B to C. So I come and then go so. Right? So BC was given as N plus 2M. Agree? See it here? Right, that's all.
Yes,
That's
sir.
BC.
Yes, sir.
And then now, this arrow is going against the truth because the original 3 over 2m was going that way. But we want to come the way
It's going to be negative.
Negative 3 over 2. Let me write the thing there properly. Last question, this, we done the paper, and we kind of done the paper in a 3 hour and a chat. We are chatting one then. What time? 7:30. What time we come on? I'm wrong. About 4 hours.
7:30. 7:30 we came on.
And at what time now? Basically 9:30. What time we have? 10:30.
10:40.
10:41.
10:41, sir.
Yes, so 10 minutes I said 10:30. That's 3 hours. And we are chatting. So that means you can do the paper at the right time. That may I talk about. Anyways, you're going to collect like terms. So N I go still there. So you're not going to touch N none at all. N not touch. All right? So the only thing now you're going to merge 2m and 1.5. Think about it. Think about this. 2m and 1, and you take away 1.5. Then a half you're left with, man. A half you're left with, you know. Think about it. This is 1.5 m. And you take 1.5 from 2. Now half m left it done. Talk to me now, man.
Yes, sir.
Hello. This is it. This is it. All right. You don't jump off. Let me just say something before. I'm going to close the live, but you don't jump off. All right, live people. Good night. We're gone. We're gone. Make sure to subscribe to your channel and share this, yeah? All right. I go close this. Let me see if I can find it. So if you close the live, yeah. Hold on.